Check, check, mic check. Check, 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 mic. 1, 1, 2, check.
Requesting all the participants and attendees to be seated so that we can start in 5 minutes. Requesting everyone to be seated. We'll be starting in 2 minutes. Good morning, everyone, and a very warm welcome to all of you on behalf of the organizing team. It gives me great pleasure to welcome you all to the CISPIN Voice Tech for All Hackathon Round 2 being hosted here at Indian Institute of Science. So today's event brings together researchers, builders, startups, policymakers, and ecosystem leaders who all are working towards one shared goal, that is building inclusive speech AI for India. This round of hackathon has also been recognized as a pre-summit event for India AI Impact Summit, and today marks the culmination of months of efforts by teams working across languages, models, data sets, and real-world use cases. A quick note before we begin, kindly keep your mobile phones on silent. We request everyone to stay within the scheduled time so that we can ensure a smooth flow of sessions. Tea, lunch, and networking breaks are built into the agendas. So we encourage everyone to interact with the participating teams. To formally kickstart the event, it's my pleasure to invite Mr. Prashanta Kumar Ghosh, who will deliver the welcome address and opening remarks. Mr. Ghosh has been closely involved in creating CISPIN dataset and models, which are hosted on AI Coach. He's also the guiding vision behind the Voice Tech for All challenge. May I now invite Prashanta Kumar Ghosh to the dais and address the audience.
Thanks, Visruth. Good morning to everybody present here and those who are coming and online. So I'm Prasanta from this very department, Electrical Engineering. The SPIRE Lab at Electrical Engineering Department, together with Art Park, has taken up a large number of initiatives in Indic language technologies and resource building. And one of them is CISPIN, which is synthesizing speech in Indian languages, generously funded by GIZ, Fair Forward for All. We have been working on that for last 3 to 4 years. And what you see today is, in a sense, culmination of all of those work that we started. And we have been hosting a series of events, Hackathon Come Challenge. And this is the latest one in that series. Pan India got a lot of response, a lot of hard work by all the volunteers, and got great submissions. And finally, we have 4 teams competing here today to be declared to have first, second, and third position. So I welcome all of you and would like you to go and learn and enjoy this journey. And finally, congratulating the team at the end of the day. And I look forward to all of your active participation, involvement in the poster and presentations, and looking forward to the teams for a fantastic competition here too. With that note, I'll finally stop saying welcome once more. Enjoy the day.
Thank you, Prashanta, for setting up the context and kickstarting the event. May I now invite Uday Kumar, Chairman of Department of Electrical Engineering, whose leadership continues to strengthen the department's role in cutting-edge research and societal impact. The department has generously provided us the venue for the event. I invite Professor to address the gathering.
Good morning to everyone. Thanks for the opportunity, Professor Prashanta. I'm a man totally outside this field. So I welcome once again all the participants, colleagues from other academic institutions, industry, young engineers and researchers for this event. I hope you will have a good throughput in the sense interaction, as well as you will get additional information on your area. A few words about department. Department is truly electrical engineering department because it has grown with the subject. We have classical areas, power, as well as the modern area, signals, image processing, and as well as artificial intelligence application to many of the classical areas. Coming back to this thing, even though I'm outside this area, for the young people, I have a small question. What is looking exceedingly simple, not really simple. Can you prove that straight line is the shortest distance between 2 points on a plane? I repeat my question. Can you prove that straight line is the shortest distance between 2 points on a plane? I do not talk about geodesics, just a plane. This question is as old as the differential calculus. The easiest to describe and solve in the case of in terms of variational calculus. Likewise, speech, what is for us kind of granted thing, very difficult to make a machine to understand or even to answer. But in this connection, I have a small one more aspect to add before I conclude. The set of words has different meaning depending on the tone in which it's delivered. This one aspect, I don't know how difficult it will be to code in mathematically. Other aspect, what I'm seeing from my experience as a word man is that we have imbibed English as a common language throughout the world. However, we have lost touch with the so-called mother tongue. So many of them have much more vocabulary for expressing human expressions. As a result of which, sometimes the translations, what is made through the readily available tools, can lead to catastrophic sentences, meaningless. As an example, Amar Chitrakatha is trying to bring out an article on Institute of Science, and because I Kannadiga, I was made a chairman for the translator version, just to verify, not to translate. My Kannada is not so good now. But the first word is so really threatening because its English word says, Institute of Science Crucible of Indian Science. The translator version says, the Bharatiya Vijnana Samsthe, Vijnana Kulume. Yes, it's a furnace. Then one more translation came, Bharatiya Vijnana Samsthe, Agni Jwale. I'm really scared of these translations. So the word may have a true meaning in a different language because the way language has evolved and developed. How to translate this into mathematical means is a mystery to me. When experts are available who can do that, and young engineers and scientists are available to do that. Just to humiliate myself, because of my great students, I had to do a small geometrical transformation, which is taking more than 2 hours. I'm not able to do, in spite of my more than 35, 36 years of coding experience and experience with vector calculus. Things are not so simple unless you delve into that. Thank you very much. Have a nice day and have a nice interaction. Thank you.
Thank you, Professor. May I now invite Prashanta to give token of appreciation to Uday Kumar. We'll now move into a set of short focused talks that brings perspectives from the industry, implementation of the data sets, and the journey behind this hackathon. To begin this, we have industry perspective on responsible and inclusive AI. Now it's my pleasure to invite Mr. Philip from ZIZ, who is joining us online, to share his thoughts on speech and inclusion.
Thank you, Bishoot, and I hope everyone can hear me well.
Yes, Philip, you are audible.
Also offline. All right, perfect. Thank you very much, and good morning to everyone. It's a great pleasure and thank you for the invitation to be here. Unfortunately, not in person, which would have been great since we have been working on this, as Prasanta already mentioned, for quite a couple of years to make this happen. So good morning, everyone again. My name is Philipp Olbrich. I work for GIZ at a project called Fair Forward, Artificial Intelligence for All, which is funded by the German Ministry for Economic Cooperation and Development. And I'm not here to take a lot of your time because I'm sure you are looking forward to jump right into things. But I want to briefly talk a little bit about why we have been working on this and how this went so far. And if we could go one slide forward, that would be great. So I wanted to briefly talk about Fair Forward AI for All as a project. So it's a global project of German development cooperation, and we are actually working with partners in 7 partner countries worldwide, in Sub-Saharan Africa, as well as in Indonesia and of course in India. And the overall goal with our partners is to promote local AI innovation based on digital public goods. So that means building on open source AI. And we do this really by focusing on 3 different areas of action. The first one and the most important one, or the one that we have focused on the most, is I think to improve access to training data and open AI technologies, because from political as well as industry and civil society partners worldwide, we heard that the greatest barrier to building local AI innovation, for example, in Indian languages, but also in the area of agriculture, is access and availability to locally relevant training data. So we have been really focusing on initiatives that create high quality data sets from scratch and make them openly and freely available to all innovators in the ecosystems. Secondly, we're also looking at building technical know-how. That means we would have AI boot camps for women, for example, that we've conducted in Sub-Saharan Africa. We have a lot of e-learning courses available on our platform Atingi, if you're interested in that. So it's really about first demystifying AI, but then also building the computational and engineering skills necessary to build it. And lastly, we have been working with industry bodies, with policymakers to develop the frameworks to both promote local innovation, but also to make sure that AI is developed in a responsible way that protects personal data and privacy. So, for example, just last week, we have launched a handbook for AI developers in India to basically translate the DPDP Act, so the Data Protection Act, into actionable guidelines for everyone to use to build responsible AI. So could we jump one slide further, please? Thank you. So if, I would like you to take one thing away from this mini intervention, it would be this kind of image of an iceberg of an AI application, because this is really how we have tried to approach this very complex problem, as was already mentioned, of building an AI application. And we really understand it as an iceberg where the AI application is at the top, is above the surface. But all that is necessary that goes into building an AI application oftentimes is not paid much attention to, and especially not in the media. So of course we hear about the chatbots depending on the application, of course, that is creating the impact on the ground, but all the work that goes in is a little bit hidden. And this is what we have been focusing on in the project, because we believe that if you are building the foundation right, a lot of different applications can be built on it. So we're addressing these different kinds of problems, including data, talent, and compute. to put innovators in a position to develop AI applications for the different purposes. So we have been working on, so you, for example, need language data, but of course you need the right expertise and computing time to build one chatbot for health advisory services, for example. But if you have built that foundation once, it could also be the chatbot could be tailored for agricultural advisory or for climate risk insurance, for very specific use cases. So as a project, we have been working with organizations like IISc, but also, of course, with Bashini, with civil society and NASCOM to get the foundations right so that the innovators can go for the application development. And if we go one slide further, I would like to briefly talk about this project exactly. As I already mentioned, we have started working with IISc about 5 years ago, where we have started to work with Prasanta and his team to really collect high quality speech data in 9 Indian languages from scratch. And there were a lot of open questions at the beginning, including how many hours do you actually need to build models that work on the ground? And we have produced a lot of questions, but of course also a lot of answers, but also of course a lot of questions. And once we had collected these data sets, they were in the spirit of the project provided as open and free data sets for everyone to work with. And at Spiral Labs, they were also turned into baseline models, so to say. And thanks to the collaboration with Bashini, it was also possible to host both data sets at the models and the APIs for everyone to access. So this is basically what is happening below the surface, if you remember the iceberg. But of course, as an Indo-German development corporation, we also want to contribute to the impact on the ground. And this is the very last step. And I think this is why you are there and why everybody is here online and why so many teams have applied to the hackathon to actually now use these foundations and build a workable solution for impact on the ground, so to say. Because building these kind of language technologies really offers to share reliable information in people's native language and just make knowledge more accessible for everyone. So I would like to thank also our partners at Bashini, at Aman, at IISc and ArtPark, of course, to make this possible, and wishing the finalists at Somya.ai, Immverse AI, CDAC and LTRC good luck, and wishing you all a successful event, and very much looking forward to the results and for how this will work in implementation. Thank you, everyone.
Thank you, Philippe, for the... sorry, go ahead.
No, I think we can, it's okay. I think we can skip this part. Thank you.
Yeah, thank you, Philippe, for these insights and highlighting the importance of inclusion from industry and development lines. And also thank you, ZIZ, for supporting such initiatives like CISPIN. Looking forward for more such initiatives and collaborations with IISc and ArtPark. Continuing in the same way, our next talk focuses on inclusive voice AI solutions and real-world use cases, particularly from the deployment and user-facing perspectives. May I now invite Ms. Kruti Dalal from Arman to share her experiences and learnings.
Hi, everyone. Good morning. And a big thank you to GIZ, Bashini, IISc, Spire, and of course, our long-standing partners, ArtPark, for inviting Arman. Philip spoke about, the multiple building blocks beneath the surface. I'm going to talk a little bit about the blue skies above the iceberg, which is, like Visruth mentioned, the real case use of a chatbot. Before we dive into the technology, it's important to understand the, sorry, I'm just going to, okay, it's important to understand the mission of Arman. We are a nonprofit that leverages mHealth to create cost-effective, highly scalable solutions to address maternal and child mortality and morbidity. So on one hand, we provide critical preventive care information directly to the women and their families during pregnancy and infancy. And on the other hand, we train and support health workers at all levels. And we do this through what we call a tech plus touch model, which means that we combine the reach of the mobile phone with existing infrastructure and network of the government and our NGO partners, which means we're not creating parallel infrastructures. And to date, interventions implemented by Arman have reached over 7 crore women and their families and supported more than 5.25 lakh health workers across India. While India's maternal mortality rate has decreased over the years, a woman still dies in childbirth every 30 minutes. Only 14% of pregnancies are currently recorded as what we call high-risk cases, but they account for a staggering 75% of perinatal deaths. So our frontline workers or auxiliary nurse midwives or ANMs, they're often overworked, they lack immediate support to detect these high-risk conditions. So with the support of ArtPark, we at Arman have built a multilingual, multimodal, LLM-powered chatbot to provide these ANMs with instant protocol-based on-job learning and support. Before we get into the actual chatbot, let's just look at the foundation. This is a program called, it's a mouthful, so bear with me, Integrated High-Risk Pregnancy Tracking and Management, or IHRPTM. It's a systemic intervention designed to reduce delayed referrals to tertiary healthcare centers. What it does is it creates a structured pathway for identifying, managing, and referring high-risk conditions in time, ensuring that they're tracked through the health system and managed well at tertiary facilities. So to make IHRPTM actionable in real time, we built this LLM-powered chatbot. So you can think of it as a digital mentor of sorts for the ANM. It's a multilingual, multimodal tool, like I mentioned, that's delivered via WhatsApp. And that translates very complex medical protocols into instant conversational advice. So what happens? How does it work? ANMs can send queries through text or voice notes, and they receive instant user-friendly answers which are pulled from these medical training protocols. For complex cases, we have a human in the loop where medical training officers or MTOs step in. We actually have one such experienced and hugely knowledgeable MTO here today, Dr. Saujanya, who is going to be on the jury. Other key features include a multimedia tutorial, as you can see, with step-by-step instructions, safety reminders, like I mentioned, multilingual, multimodal, very prompt feedback after every answer, and escalation to a human if the question is out of scope or potentially harmful, or if the user is not satisfied. This project didn't start in a lab. It started in the field. So our journey began by shadowing ANMs to understand their daily workflow. We moved from a simple rule-based system to the current LLM-powered model. We launched pilots in UP and Telangana and iterated that technology based on real-time feedback. And now, by Jan 2026, we have scaled to 3 states, and we are constantly refining the AI's ability to handle complex medical queries. So we at Arman, we believe that technology must fit the human, not the other way around. And we maintain a deeply empathetic approach. And we recognized through our on-ground experience that ANMs face immense pressure and fear of making mistakes. Hence, we designed the chatbot to be a judgment-free zone. It's a safe space where they can verify a protocol without fear of being penalized by any supervisors. The results speak for themselves. In our current expansion, we have maintained a 98% positive feedback rate in Uttar Pradesh, which is where the largest deployment is happening. As the LLM has learned from thousands of interactions, human intervention has now dropped significantly, as you can see. So only about 12% of queries are escalated to the MTO, which allows the MTOs, our medical staff, to actually focus on truly complex cases that need their attention. I'll just show you some quick examples of real queries by ANMs. As you can see, there's a mix of languages, some incorrect spelling, incorrect grammar, and the chatbot can answer it all. These are some of the sample answers. As you can see, the chatbot will respond in the base language. So in the case of UP, that's Hindi. And medical terminologies are often referred to in English, which is what the ANMs use in their everyday language as well. Of course, there are challenges, there are learnings. So despite our success, our human-centered research highlighted a gap, which is digital literacy. While ANMs love visual cues, visual posters, they often struggle with like pinching and expanding images on small screens. They know that information is there, but physical interference sometimes gets in the way. Another learning is that while it's functional, typing long terms like preeclampsia while examining a patient on the ground can be a significant burden. So going ahead, our roadmap for 2026 is centered on transitioning from a chatbot to an assistant. So we are moving from what is currently a pull model, which is waiting for a response to your query, to a push model where the bot will send out nudges. It will send out bite-sized multimedia audio lessons to keep that knowledge fresh. And for our innovations to succeed in the long run, especially as we scale to over 12,000 more ANMs and also move to a new linguistic zone like Assam, voice is going to be our primary lever. Voice removes the barrier, like I mentioned, of typing in real-time situations, and also removes that barrier of local script literacy. You need not know exactly how to type in the local language. Also, speaking or talking about a symptom is the most natural way to communicate something in a clinical setting. And going ahead, we are planning to introduce a similar chatbot for pregnant women and new mothers in low-income communities, especially in the urban settings. And this is where you, the finalists, all come in, because when we master voice, we will bridge more gaps in maternal healthcare equity. So looking forward to the finalists sharing their work, and all the very best. Thank you so much for having us.
Thank you, Kriti. May I now invite Prashanta to do the honors. At the core of building inclusive speech AI lies the data, how it is collected, curated, and governed. Our next speaker, Deekshita, will walk us through the database creation process, including an overview of the R dataset, CISPIN, and the SPICOR dataset, along with some important guidelines. Please join me in welcoming Deekshita.
Thank you. So let's have an overview of the data sets that CISPIN and SPICOR. Those are the backbone of this today's hackathon challenge. So let's see what all efforts we have taken to release such a huge data set that's really contributing to the community. So coming to the highlights of the CISPIN data sets, currently it's the largest scale Indian TTS data sets that's available, that is designed by the Spire Lab of IISc Bangalore. Then it contains of 900 plus hours of speech, good quality speech data across 9 Indian languages. So it includes 9 Indian languages across 18 speakers, both male and female are included. With this data set, we are able to bridge the language gap that is existing in the research community. And this data set helps to support the academic and industrial research community to enable with good voice technologies. And we are critically helpful for enabling the low resource language. Similarly, Spycore also, here we are focusing on Indian English as well as Gujarati data sets. We have 97 plus hours of Indian English as well as 57 plus of Gujarati. Here 2 speakers are there for both male and female, including English and Gujarati. And it captures Indian accent English as well as it's useful for English TTS systems with the Indian accent. And we are, with the Spycore data sets, we are focusing on 2 Indian accent and languages. So this is the backbone of the Spycore or CISPIN dataset preparation. First, we started with text preparation. Then we selected the voice artist. Then recorded the recordings in the studio. Then we had the data checks and curation process. That was a huge process to get the clean data. Then data hosting, followed by the models and data hosting, model building and challenges. So let's see in detail of each of these blocks. So I'm going to explain the same process through the language of Magahi. So here, if you check for the Magahi, there were no pre-existing data sets. So the existing sentences that we are able to collect were 0. Then we got some books with the help of some OCR technologies. We have extracted some sentences. Then with the help of some native people, after getting them selecting through some rigorous process, we selected some native speakers of Magahi. Then we composed around those sentences, and all together we got some sentences, and after that we collected the, we shortlisted the sentences and came up with 26,000 sentences. For the composition part, we have given different domains to the native speakers to compose sentences from agriculture, finance, health, social related domains. So these are the domains that we have covered, and these many sentences we have composed. So this is the same block. So this is the overview of the 9 languages that we have collected. So many existing OCR sentence composition total and after the post collection. So next is the voice artist selection process. So there also we were not aware about who is the best artist, who is going to speak it in the native style. So we posted the job in different job portals, social media web pages. So people applied. Then we asked them to record some pilot tests to select the best among them. Then there were some tests like voice quality and reading proficiency tests were run. Then we asked the native people to select the best among them to who is speaking in the native style. Then finally, a best voice artist from the male and female community was selected to do the recording process. So same thing I will explain for the Magahi thing. So around 20 male applicants registered to the post of voice artist of male, 11 for female. Then pilot tests were attended by 16:9, male is to female. Then reading proficiency test was done for 12:4 only. Then among that, RP was good. Reading proficiency was good for 2 and 2:2. Then we asked the public to select. So there were around 67 who voted for male and 46 attended for the selection of female candidate. Then among them, we selected the best male and female voice artist who is good to go. Then let's see the studio recording and details. So this is with the help of the data partner of this CISPIN project was Finalist Studio. So with their studio setup in the Bangalore, we had these recording sessions. So these are the screenshots or photos from the studios. So there also we faced so many challenges in selecting the voice artist as well as for the talking with them. So the already trained voice artists they were busy with their own schedules and all. So it was difficult for them to come to Bangalore and do this recording. Then some senior people were arrogant to why they should do the pilot test again. We are already well-known persons, no? So why they should do. Then language and communication back between us, like we are speaking English or Hindi, Magahi, Bhojpuri kind of language was difficult for us to handle. Then taking long time to share the pilot, so it dragged the process. Then they were not able to shift to Bangalore for at least 1 month because the studio has to be there. We cannot record all the things in one day itself, we cannot close. So there is a time of 1 month, they have to stay in Bangalore. Then some instructions they had not ready to follow. Then they were eagerly trying to finish the sentence recording in 1 week or something like that. They can go and back. So now let's see to the data checking and curation process. So after the recording, Bhashini Studio has shared the recordings to us. Then the data checking happened here in the Spire lab with the help of team members, programmatic as well as manual. Then we gave the feedback to them, Bhashini. Then they corrected this. Then again, the correction process happened, that curation, cleaning, manual validation, programmatic validation, all those things happened. Finally, we published the data. Again, back to the story of Magahi. So total duration of collected data set was 55 hours for the male and 1.19 for the female. Coming to the final data, out of that, after so many rounds of curation, 54 we released for male and 51 for female. So this is the total stats of the all languages, what we have collected and what we have published. So coming to the data hosting, we have hosted the data sets in this page. So here it can be customized, like which all language you need to select, you can select that proper one, or which gender you want to select. And there is 2 more options, like there is human checked as well as non-human checked is there. So you have the option to select anyone. So it's customized, you can select as per your requirement. Then this is already hosted in the AI Ghosh webpage as well. Our CISPIN dataset is available there as well. Coming to the data downloads, here you can see like database is being downloaded across the world, with most of the downloads happening in India only. And here you can see like CISPIN has that much downloads. All languages are being downloaded, and Hindi and English also having high demand. Then the baseline models are hosted in the CISPIN IISc Spire Lab Hugging Face page, and it's also being used as the model for the Bhashini Anuvad page also. So here you can select the Bhashini IISc V1 model while you use the Anuvad. Coming to the challenges that we have organized with the help of CISPIN SpyCore datasets. So we had 3 events or 3 challenges: limits 23, limits 24, and limits 25. So these are the details of the registrants and the participants who attended the sessions. And of course this hackathon also. So coming to the summary, CISPIN or SpyCore enabled us to have a large-scale multilingual English TTS system. And all datasets are open source and open for the research community. And it is inclusive for and scalable for any development in the speech AI in Indian languages. And apart from this CISPIN or SpyCore, we have, or the Spire team have, other datasets as well for different applications like Vani, WSpire, SpireIMA, Raspin, VCV, Indictimate, SpireSys. So these are of different applications, ASR, IMA, all those datasets are available. So as a future work, we are trying to expand the dataset with more languages, more speakers and sentences. Then we are planning to increase the diversity of the speakers and strengthen to cover more low resource languages or underrepresented languages. So in SpyCore, recently we are doing the Santali and Saurashtra language. So we are planning to conduct more workshops like this and to share the task and research challenges. And as always, we are always open to have collaboration or all kinds of contributions, and community supporters are welcome. So to know more about the Spire Lab or updates to have the data, you can scan these QR codes. Then we, the Spire members, are working with a motto of advancing Indian speech AI through Spire Corpora. Thank you.
Thank you, Dikshita. We have 5 minutes for the Q&A. Any offline participants or online attendees? If you have any questions on the database creation process, Dikshita is here for you.
To introduce, I am speaking in Sanskrit.
Okay.
I'm an alumni also.
Okay.
And we are a startup called Startup Sanatana.
Okay.
Especially whatever you are doing is a beautiful work. And we want to bring the same kind of technology, especially to the Sanskrit and the Vedas kind of thing.
Currently, we are doing the Saurashtra recording, so we are focusing on different languages like this also.
Yeah, if you can help us, definitely we will also, we would like to be part of this endeavor,
sure,
and
sure.
okay, it will help, our thing also. And I saw one sample in IISc Open Day. I was curious to, implement that one. And we are building a use case to demonstrate, we are trying to meet the Prime Minister Narendra Modi ji also. At that time, we wanted to showcase that one. If you can really help us, definitely we'll be glad and we'll be thankful to you.
Sure, sir.
Hello, thank you. It was a wonderful presentation, and I'm impressed by the amount and the size of the work, and also that you are also targeting beyond 22 scheduled languages. So I was estimating. I'm willing to know how much do we cost per hour estimate. I know big projects go in crores, but we want to do it. Want some estimate.
It all depends upon the hours of data we want to collect.
Yes, so, like, if you want 100 hours, so how much it may cost, like, with this process?
Maybe Professor can answer.
Thanks for our question. I mean, as Professor said, the cost per hour changes depending on the language. It's a high resource language, so certainly at a low cost per hour. Also, it depends on how detailed is the process and how you want to get the recording done. Right? For example, for the CSPIN project, we had to build the studio, high-quality studio there itself, right? That costed independent of the language, so that cost will go into the languages. It also depends on if you want to get a good artist, voice artist from the local region than somewhere in Bangalore. It depends on many, many factors. So it's very difficult to quantify and tell what's the cost per hour. I need to calculate and tell you. But overall, this project for 9 languages costed nearly 4 crore, I would say, including all the 9 languages.
Okay, thanks.
Thanks for the presentation. Myself, Dr. Bhuvan, I'm an associate professor from St. John's Medical College, Bangalore. So what is the relevance with with this kind of technology in case of healthcare? Like we heard from Arman on. So what are the different data sets which are in pipeline related to the healthcare? Because this is of course on the maternal and child health, but what about other chronic disease conditions such as cardiovascular disease, respiratory, autoimmune disorders? So whichever are the healthcare conditions which require the continuous monitoring, follow-ups, that continuity of care. So I can see a lot of use cases utilizing this kind of technology. So I just want to hear more on that. Thanks.
That's an interesting question. See, in preparing the CSPIN corpus, we ensured that the sentences are domain balanced, so that in the event you want to deploy in a specific domain, that those kind of words are not fully unknown or out of vocabulary. However, having said that, this will be a generic purpose TTS. So if you'd like to build a TTS to be deployed for a specific application which has very technical terms and jargons and terminologies, then it could be useful to do certain fine-tuning on this corpus on top of a model built on this corpus, so that it works very well in that specific domain, right? So currently, if there are certain general purpose sentences covering various domains, like as Dikshita pointed out, as you see here, right? Agriculture, finance, health, social, right? However, probably it will struggle to synthesize medicine names, for example, right? There will be very complex chemical terms, right? So for those, we may have to do some fine-tuning. But at this point, this will cover, in general, broad coverage of the domain.
She asked about other data sets also. She asked about other data sets also. Like ALS also, we have data sets.
Yeah, I mean, so in terms of the work that we are doing, in overlapping with healthcare, We are working with Nimhans in Bangalore, for example, to create, we have been working for last nearly 8 years to create data sets which can help us identify biomarkers, speech biomarkers, for early detection as well as classification of neurodegenerative diseases. That's one category. We're also working, overlapping with healthcare applications with St. John's Medical College and Hospital in Bangalore for respiratory diseases, how that gets reflected into sounds that humans create. So all to monitor the health parameters from speech, because speech is an acoustic signal which will get affected if your respiratory systems or neural disorders happen. So those are the scientific questions we're interested in. However, I would say they are not really in a form that can work really accurately on deployment.
Yeah, very nice presentation. So because I know how creating such speech corpora and like translation corpora is a major headache. Okay. So one question I want to ask you, like I'm working on video summarization. So what we did, we crawled a lot of data, but one thing, in order to have a publication, you need some benchmark data to be human validated. So because normally when funding is there, then you can go for creating data set where you can pay. But when you do not have funding, so are there any approaches where you can do some kind of crowdsourcing and then create some kind of benchmark which may not be completely gold, maybe bronze or silver? Okay. So have you come across such things, like any attempts like where people, because they can't create gold benchmarks, because they can't create gold benchmarks, they relied on some other techniques?
Currently, we have published based on the challenges we have organized. So there, the model developed are of good quality or golden style only. So we were able to publish the papers. Then as a data set, we were putting the paper, or we published as the effort we have taken or the process we have involved in the building up of this data set. Base model wise, we also don't have that much golden standard kind of thing, but through the challenges we have received.
Thank you.
But let me address your question. I think that's a thoughtful question, right? Because creating a gold standard or maybe platinum standard would require time, bandwidth, manpower, all of that. Now it depends what kind of data sets you're talking about, right? If it is, let us say, an ASR data sets, yes, probably crowdsourcing will help. But as of today, the way even multi-speaker and multilingual TTS works, if you have recording condition variabilities that the models often do not generalize or are not robust to those, right? So having, there are very few data sets where we have a large number of speakers and less hours per speaker or minutes per speaker, but that are in similar condition. Otherwise, the models will go to modeling those and then it doesn't work. So depending on the target application, could be possible crowdsourcing, but for TTS, my quick thought will be probably not that easy, but we have to think through.
So hello everyone. I would like to know about how you validate the data accuracy, and in terms of technical challenges, what are the technical challenges you face in this whole process and how you navigate into that?
So while data cleaning process, as I told, we had several rounds of cleaning process was there. Let me come. Sorry. As I told, there were manual as well as programmatic evaluation was there. So in the manual validation, we have hired native speakers from the native language itself through some selection processes. So they manually gone through each and every audio and text file. So we have a web app set up to validate whether this file is paka correct, matching with the text, or any tongue slips happened, or any pronunciation mismatch, or any extra noises added. So each and every file that we have shared through the database page is human validated, first of all. Then all kind of programmatic checks that are available by us are also done. Like we had done like energy-based checks, spectrograms, speaking rate-based, all kind of checks, or clipping is there. All kind of programmatic checks also we have done. So that data is curated, and that programmatic as well as manual basis. Challenges in the sense, in every stage there were so many efforts were there, or challenges were there, but we had overcome all those things.
Yeah, just to add to what Dikshita said, there are a really large number of checks that we do. Think of this way, there is a voice artist, records for 40 hours. So let's say considering a sentence of 8 seconds, you can easily calculate how many audio files you will end up having. And each audio file ideally should be manually checked, and we do get that done. But first we like to see if we can automatically flag some of them having problem. And to automatically flag, there are a large list that we do. I'll just give one example, which is quite non-trivial to think about, and we discovered that. So before speaking, because we are recording in a high-quality studio, so even a pin drop will get recorded, right? So what happens before every sentence, the speaker takes a deep breath, and that recording goes in. So we have to make sure that we really don't include that in the beginning. Otherwise, what will happen, probably during synthesis, every synthesis will begin with, and that happens. So imagine, this is something that we learned. I mean, we didn't, had really thought about before. And like that, many more. So these are, we can't make people to listen to this and cut. So we have to automatically come up with techniques that will automatically remove these in the beginning and then these breathing sounds.
Here also you can see like how much data we simply wasted, because after cleaning this much we have collected this much for May, but actually released this much only because of some errors in that.
Thank you, Dikshita. May I now invite Nihar Desai to give the honors to Dikshita. Every initiative like this has a story, a vision, a journey, and many learnings along the way. To share the story behind the Voice Tech for All hackathon, including how it evolved and what it aims to achieve, I invite Pranav and Jasraj.
Thank you, Vishruth. Hello, everyone. I hope I'm audible. Okay. I'm Pranav. I'm here to give you an overview of the Voice Tech for All hackathon, challenge, and showcase how we took this from a concept to a real-world initiative. At the core of the challenge, we proposed the following problem statement. Develop an advanced multi-speaker, multilingual text-to-speech synthesizer that supports accent and style transfer through zero-shot voice cloning, with a strong focus on efficiency, scalability, and output quality. To break this down, the model must be capable of multilingual. Capable, meaning the synthesizer should be able to synthesize audio from multiple languages. It also must be multi-speaker capable, meaning generating speech for multiple speakers. To achieve this multi-speaker capability, the system must employ zero-shot voice cloning, where the model is given a single speech utterance from an unknown speaker and must accurately mimic the speaker's vocal characteristics, including tone, accent, style, etc. To simplify this further, here is a demonstration of the system that we are looking for. The image at the center is the model, which takes in two inputs. One, the text, and the reference audio. The reference audio sounds something like this.
ఇది సాధారణంగా పరిగణించబడుతుంది 2 అయితే మీరు చెప్పినట్లుగా కళ్ళు
With the combination of these two inputs, here is the expected output.
ఇచ్చిన సందర్భంలో రెండు గర్భధారణల మధ్య.
Here is another example of the same. Here we have Hindi text and a Hindi reference audio, which sounds like this.
अंडर ग्रिप यह मैन्यूवर यूटेरस के ऊपर वाले हिस्से को महसूस.
And here is the expected output.
पहली तिमाही में एरी जांच की जानी चाहिए.
So in essence, the model must generate synthetic speech for every. So in essence, the model must generate synthetic speech from a single previously unseen utterance and does so for across multiple languages. The languages selected for this task are Kannada, Hindi, Bengali, Marathi, Telugu, Bhojpuri, Magadhi, Chhattisgarhi, Maithili, English, and Gujarati. We will be getting to those. Seems to be an error. We apologize for the technical difficulties. Yeah. So the next question is, how do we create an initiative that achieves this? We addressed this by defining 5 key components that form the foundation of the challenge. They are: attract a diverse set of capable teams, provide data sets to them, release a baseline and provide a structured challenge, define criteria for evaluating these models, and offer some meaningful awards to help motivate the teams. To reach a diverse and talented pool of participants, we collaborated with Next Chapter Studios. And with their help, we ran advertising campaigns across platforms such as LinkedIn and Twitter to spread awareness and invite participants. In addition to digital reach outs, we also engaged directly with the potential teams in person. Can you just remove this? It should be good. Okay. Finally, we amplified our outreach through our collaborators, Bhashini, GIZ, and Arman, whose network helped us connect with researchers, startups, and academic teams across ecosystems. We really do apologize for this, but I guess it keeps dying. Okay, thank you. As a result of our marketing efforts, we achieved over 400 registrations spanning 21 states and union territories. These participants represent a highly diverse range of professionals, academics, and cultural backgrounds. Next one. I think you skipped. Okay. Sorry. To ensure all participants share a clear understanding of the problem statement, and to clarify any questions the teams may have about the finer technical and logistical details of the challenge, we conducted an introductory webinar on the 15th of November 2025. This session lasted close to 1 hour, including a dedicated Q&A segment, allowing participants to clarify any doubts that they may have and align their understanding with the challenge's expectations. This webinar had over 150 attendees who joined the session live. To ensure accessibility for those who were not able to attend these online event, we shared a recording of this webinar via email and also made it available on the Voice Tech for All website. I think, yeah, still have a problem. Okay. That concludes the first element of the challenge. Moving on. Next one, please. Now that we have successfully attracted a diverse and capable set of teams, the next step was to provide high-quality data sets to help them train their models. The data sets in question are CISPIN and SPI-Core data sets. For those interested in learning more about these data sets, or for anyone planning to use them for their own projects, we have included 2 QR codes. The links, these link to the the SPI datasets website and the CISPIN webpage of the AI Coach website. Okay, sure, that's also fine. Right. We have diverse sets of teams, and we've provided these teams with high-quality datasets to build and train their models. So our next goal is to release a baseline that establishes a minimum performance bar and design a challenge track to ensure the teams exceed it. Next. Yeah. The challenge was structured into 2 rounds. Round 1 was an online phase, during which teams were required to submit APIs of their models built in accordance to certain specifications that we had provided them beforehand. And based on their submissions, we would shortlist teams to advance to round 2. Round 2 was an offline event, which brings us to today. Following a rigorous evaluation process conducted by an experienced jury of domain experts, we then select the winning teams. Here to talk about the baseline and the nuances of the challenge, my colleague Jay Suraj.
Works. Thank you, Pranav. Hello, everyone. I am Jay Suraj, so I'll be continuing the presentation. Starting with the baseline that we released. So we trained the Your TTS, a multi-speaker, multilingual TTS model with zero-shot voice conversion capability. We trained it on complete CISPIN and SPI-Core datasets about which we already discussed. And we open sourced this model along with the training and testing code base. And we also open sourced the script required to run an API endpoint because that's how we ran our inference. So the participants were supposed to host API endpoint, and we would run our inference script to get the synthesized audio. And we provided the code for the API as well, so that it helps the participants. Okay, so next we move on to team selection process. Yeah, so this is the overall flow of how round 1 happened, basically. The participants submitted the API endpoint and technical write-up for their system using a Google form. We ran inference on a test set using the API endpoint provided by the participants. To evaluate the quality of the synthesized audio, we used objective metrics. So after using these objective metrics, we shortlisted 10 participants, and the audios of these 10 participants were then sent for subjective evaluation. So I'll explain what these objective and subjective metrics are in the next slides. But overall, we use these two different sets of metrics and finally compile the results by averaging the scores across all metrics and shortlist teams for round 2, which is today. Yeah, so another thing is for shortlisting, in addition to these metrics I just talked about, we ensured that the submission followed certain guidelines. These guidelines included these API standards, uploading the code base to Hugging Face, by which these models and training and testing script can be open source. And then, like I mentioned, the participants were supposed to submit a technical write-up as well. So, yeah, so this is the exact workflow, which we'll go into details. So the first thing was if the submissions comply with the guidelines. So based on that, we had to shortlist the teams. If the submission did not follow, we had to reject because the guidelines were very clear from right from the start. So once we received the API endpoints, we ran our inference scripts and we received all the synthesized audios. So like I said, there are two sets of metrics. First one is the objective metrics. For objective metrics, we used an ASR system to generate text from the synthesized audios, and then we compared these generated text with the input text and got a score which we call word error rate. Then the other objective metric was speaker similarity score, where we used a speaker embedding model to get embeddings for both the reference and the synthesized audio, and we compare these embeddings to get a speaker similarity score. So for the subjective scoring, we use mean opinion score. Basically, what we do is we take all these synthesized audios and give it to experts who rate the quality of the audio on a scale of 1 to 5. And we used all these metrics to get final score by averaging it across all the metrics. And so for round 2, we selected top 4 teams, and they're all here today. Yeah, so these are the finalists. And yeah, for round 2, the evaluation process more or less remains the same objective and subjective scores. But in addition, we have something called jury evaluation. So in this, we have a jury of experts in the domain of speech technology who will evaluate the submissions on 5 different aspects. So the aspects are technical write-up, which is basically how well the methodology is explained in the write-up. Second is technical novelty, which is basically how novel the idea is. Then the quality of synthesized speech. Next is Q&A performance, so how well can the participants answer the questions that are asked to them by the jury. And the last one is poster presentation. These jury scores will be included in the final selection of winners, and the final ranking will be decided based on average ranking across all these metrics. So next, I'll be playing some of the sample audios we received from the 4 teams. I'll also be showing the text and the reference audio that we provided. So the reference audio and the text will not be the same utterance, but we expect the output to have the same text and the speech quality and speech characteristics of the reference speaker. Yep. Can you go back 2 slides and play the audio? This. Yep.
నడుము నొప్పి తీవ్రమైనదిగా ఉంటే లేదా రక్తస్రావం జ్వరం లేదా ఇతర అసాధారణ.
Okay, so this was the reference audio and the text input can be seen. So
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చడం.
okay, so this was the synthesized audio by the model submitted by CDAC. Yeah, also we have chopped the audio for 5 seconds. This is not the complete audio.
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చడంలో ఎర్ర రక్త కణాలు.
Yeah, this is from Immverse AI.
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చడంలో ఎర్ర రక్త కణాల
This is from LTRC and.
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చడంలో.
Yeah, so this was from Somya.ai. So you could notice that it's for the same text and same reference audio. There have been different characteristics that have been captured by these systems. It may be speaking rate or their pitch or the way the reference speaker speaks or the accent. So there are multiple attributes that we would want the model to capture, and these final models have done pretty good job. Okay. Because of the timing for presentation, I had to chop it for 5 seconds. We don't have Kannada in the presentation, so we'll share it later. Yeah. Okay, so now moving on to awards and prizes. Yeah, so to provide motivation to all the participants, we have very exciting prizes, as you can see. Okay, so I would like to thank everyone without whom this event would not be possible. I thank Bhashini for enhancing visibility of this challenge, IISc for providing background support for executing the challenge, GIZ for financial support, ArtPark for providing team support and program management, and finally Arman for collaborating on defining the problem statement for the challenge. Thank you, everyone. And I guess we have time for Q&A. Yeah. If you guys have any questions.
So what was the volume or size of the test set that you used to evaluate?
Okay, so we had around 1,000 utterances for the test set. I don't think I can go into details about how many speakers we evaluated over, but yeah, it was about 1,000 utterances in the test set. No, test set is not public. That is the, yeah. Yeah. We had to pick one subjective evaluation metric, so we just went with MOS because previously in challenges with this data set, we had done a similar evaluation and it worked well for us in terms of judging the model, so that's what we went with. But that's something we could explore in the next challenge. Yeah, that. Okay.
The MOS scores will be higher.
Okay.
For the synthesized voice than for the.
Okay.
So it's always, you Should do degradation most.
So the user bias, you mean basically?
User bias will go away when you.
Okay. I guess that's a very valid point. Although we did provide these instructions that you're supposed to score it just based on the quality and using the reference speaker characteristics, but that's a valid point. I believe in the next challenge we would look into it.
Can I ask a general query?
Okay.
Hello.
So,
So
one second.
Let her come.
Okay, you can.
So the question is, like, we already have some of the Indian government recognized players like AI for Bharat and Sarvam, which is like basically from IIT Madras, I think what I heard. So, and then when I see here, you initially claimed that we are going to be open source. Like even the form which we filled initially, all the players, all the top finalists, you are going to make it as open source.
Yeah.
Both their models, data sets. I think data sets also you want to make it.
If it's a closed data set, they are supposed to mention it, but if it's open data set, we mostly took information about the data set used, is what I believe.
So my question is, because see, if you look at AI for Bharat and those IIT Madras Research Park offerings, right? So what level do you think, suppose if you make all the data sets, at least the models, forget about data sets, at least the models, if you make it open source, do you think like there's a competitive spirit or there's a collaborative spirit which you plan to see in the near future?
My opinion at least is, and from working on the data set and the challenge itself. Can you? Yeah.
And then there is the third play, which is Bharat Gen from Professor Ganesh, which is coming from IIT Bombay. So the question still remains same, that what is the convergence? Are we looking at something which is converging all these three, or it's a competitive spirit that we want to be better than Bharat Gen and Sarvam / AI for Bharat,
I don't think, at least speaking in with the perspective from the lab and what we believe in, we mostly are trying to open source most of the data set and models. So our goal is to collaborate and build technology that is accessible to everyone. So at least that is what our vision is. And in terms of different labs and different companies collecting data, so one of the important things that makes our data unique is the sentences or utterances that we have are from different domains, and we have these domain-specific sentences. That is, I think, one of the important things of CISPIN and SPICOR dataset. And I think Professor would explain more about this.
I think that's a good question in the current context, the way various efforts are being taken into creating open source data sets, right? But I think we should look back a little bit in the history. So here, Professor Hemamurthy is here. She has been, leading. He has led a number of consortium projects in the past. But if you look back, let's say even 5 years before, right? There have been a lot of effort being put in, but it has really intensified in the last 5 years. Right? So at this moment, at this juncture, it's very important to think the way you are asking the question, that whether it will be collaborative or competitive. And I mean, in the beginning, when there is very little things, let it be collaborative, let it be competitive, let something come out is the approach. But now going forward, I think we should certainly sit together, discuss, and then see whatever we create, they together becomes valuable, not something repetitive, right? And we have discussed that with Professor Mitesh, Hema, Umesh, everybody. And I think when we write the upcoming proposal, and that's where this consortium project really helps, as IIT Madras is leading now also, and I'm part of that too, where we really distribute the work so that multiple people do not end up doing the same. So thanks for the suggestion and thoughts, and we are indeed thinking.
So because I always feel that while you are saying that there's a consortium, but I always feel that there should be a competitive spirit, because unless that is there, if it's always a collaborative, people will not excel. So I think everybody is recognized nowadays that Ashwini Vaishnav recently launched the list, right, where So I think, yeah, all the players are there, but still, unless the everybody got the funding also, they have got, I think pretty much you also must have got the GPU allocation, so every player, IISc Bangalore, IIIT, everybody is getting the GPU allocation officially from the government of India. But still, what I believe is that there has to be some edge that, we want to be at the top. Only then we will be able to. So yeah, for that, I don't know, because even Sarvam and other players are keeping some of them as open source, some of them as non-open source, like some of them as like proprietary. So I just wanted to ask you, right, that do you really think that keeping everything open source is going to make sense? Because then you are literally not, keeping the margin for, yeah.
Let Hema comment.
Who that was who asked the question. Since I lead this consortium, I can tell you that Indian languages, there are not too many players. And the fact that all of us speak only in English and not in our native mother tongue. How many of us even write in our mother tongue is a question. The question is if we really want this technology to reach the people who are one step, a delta function below us, we cannot do anything but put it in open source. Once you start pricing the technology, data and software, the last mile reachability almost is completely zero. So that is why it has to be open source for a while. And in the Indian context, this is something that we really need to worry about. I agree that the Sarvams, the IIT Madras stuff and Mitesh Kapra and all, we have had the benefit of CDAC resources. There's one very big disappointment for me as consortium leader that we have really not focused on the Indian ethos or Indian ecosystem, where we should be building very small footprint systems. We can neither afford the energy nor the GPUs that we want. Again, that's going to marginalize. In fact, I would have liked that you had something on footprint of the TTS systems. That what is the size of the footprint? It cannot be that I'm training for 40 days on GPUs provided by CDAC. It has to be trained much smaller footprint. And I think we could do it and we can do it. And this is something which I feel will be the driving force. I don't know how many of you know Qualcomm, Samsung, all of them are investing on edge devices which can do a lot of the stuff for us. Copying the West, riding on, in fact, riding on wits and riding on, I don't think is the correct way to go about it. I mean, but we had to start somewhere. We have started in the last 5-6 years. We made some progress, and the consortium was formed primarily getting all the people across India who's who in a particular technology, put things together. Maybe the future will start getting better for us.
Yeah. Mine was a very generic thing. After seeing that, text to voice kind of thing. Just imagine a hypothetical case where, a small text portion is there, which is written in English, where, we have a challenger like RAMA, and we don't know the context and this one. The same RAMA is, it could be feminine or this one masculine, Rama or a Rama kind of thing. Then how do we, in such a, it's a very simple example. How do we judge, saying that this one, whether it's Rama or a Rama for a simple RAMA?
So generally for TTS systems, in terms of how the pronunciation is and the word that is said, we use word error rate. Basically, we take the audio, give it to a speech recognition system, it generates text, and we compare the text. So
no, what I'm telling is text to the voice.
Yeah. So when you have this TTS system, you give it text like RAMA, it generates either Rama or Rama, right? So one of the ways we evaluate it is we have this speech recognition system, we give this audio, and that model will transcribe it. It will write the text for this audio. Yeah. So when there is this pronunciation changes, right? If the speech recognition model is good enough, it will transcribe it as RAMA. That is one of the things that the TTS models are evaluated with. And
the system gets some kind of hint.
Okay.
Yeah, that's what.
During translation, it always assumes that the gender is male.
Yeah.
This is a problem that we have. But not in TTS or in ASR. In speech recognition and synthesis, this problem will not be there because you're giving the text in the Indian language.
Yes.
That will not be a problem.
If the
problem is text-to-text translation. That's
Okay.
where it messes with the gender in a very big way. Because when you say avaru, for example, are we meaning woman or man? But it will say man in the translation.
Why so?
The reason is because we are trained with a lot of data from men. That's the problem. There's a bias in the machine translation system.
Anyway.
Yes, sir. So, like, what type of RAG
I think
applications are you being?
we'll take these questions offline during the break. Yeah. Yeah. Thank you, Jaisraj and Pawan, for giving us the glimpse into the sheer amount of work behind this hackathon. May I now invite Nihar to give a small token of appreciation to both of these? We'll now break for tea and coffee, followed by poster presentations in the corridor. And from 1 to 2, we have a lunch break. And then again from 2 o'clock, we have team presentations from all the finalists, and then the evaluation follows. Yeah, the tea coffee is also in the corridor, followed by a poster session. If you have any questions, you can interact with the professors and also with the teams. Thank you. For all the online participants, we'll be back to the room at 2 o'clock, where we'll resume with the team presentations. Please hang on till 2 p.m. We'll be starting in a couple of minutes. Welcome back. We now begin with the team presentations where all the finalist teams will present their solutions to the jury members. Each team will have a fixed slot and we request all the teams to strictly adhere to the allotted time. We have 15 minutes max for the presentation and 5 minutes for the Q&A. Now I invite CDAC and SVNIT team. The team comprises of 2 senior scientists from CDAC Noida and 3 assistant professors from SVNIT Surat. This interdisciplinary team collaborated under the Voice Tech for All Hackathon initiative to design and develop a unified multilingual multi-speaker TTS system combining expertise in speech technology, research, system development and academic innovation. Now I invite the team onto the dais.
Good afternoon all. So we are team CDAC-SVNIT. We are a team comprising of CDAC Noida scientists and academicians from SVNIT. So our title is a unified multilingual multi-speaker TTS model with one-shot speaker style transfer, which will be like explained why we are writing all of this. Okay. So so keeping it short, the motivation and all those things, the challenge is designed for under this motivation that the linguistic diversity of India is very high, and it's highly challenging to create scalable TTS systems. So we also we have a famous saying like the dialects change in every 10 kilometers in India. So for identifying the speaker specific characteristics, it also becomes challenging to design TTS systems which take into account the speaker characteristics, as well as so this challenge also comprised of many extremely low resource languages where many NLP tools or voice tools are not available. So under these settings, how we are going to design a TTS system which is reliable was the main challenge. So so our model, so there are major 3 strengths of our model. So we get away with the language specific phoneme systems while designing our TTS models, and we have shared parameter models, and with very minimal speaker data we can adapt to any speech, or we can clone to any speech and generate TTS systems. So the executive summary of our complete work is presented in this slide. So we are creating a multilingual TTS system which is supporting 11 languages, and other Indian languages can easily be incorporated into it. And this word error rate is less than 25%. So it's like whatever the TTS system generated, we also took a off-the-shelf whisper ASR and checked this. So the word error rate can also vary based on the ASR system which we choose. Like Indic ASR may be better for Indian languages. So, and we have a very fast system, and we also showed that the inferencing time is very low, and we can support like 6 requests per second. So the major technology integrates the WITS model and free voice conversion. So it's a one-shot voice conversion which will be further be explained by Mukund.
Good afternoon, everybody. So this was the architecture that we followed. As you can see here, a user can give code mix text like today's meeting early hobe so please jaldi aana, and that goes into our WITS model. In the reference audio, we extract the speakers embedding, and all the neutral speech and the speaker embedding goes to voice conversion module, and then we get the cloned output. So basically, this is a two-stage architecture. First one is WITS generating the neutral speech, and FreeVC converting the voice to your personalized output, you can say. So coming to the what basically vanilla WITS model is. Basically, it comprises of three basic modules. First one is the text encoder, which encodes the linguistic representation of the text. Second is the stochastic duration predictor and posterior encoder, which basically aligns the acoustic model with the linguistic representation. And finally, the hi-fi gain decoder, which synthesizes the representations into the waveform. So here, if you can see here, we have prepared a unified grapheme inventory of 500 characters. So in a way, we wanted to remove the dependency on phonemization of the transcript that we have. The voice tech challenge round had some of the low resource language like Magahi, Chhattisgarhi. For that, building a G2P tool was difficult. So we unified that grapheme inventory as they said the same Devanagari script. And then we trained the WITS model. We also conditioned the language embedding as well as the multi-speaker embedding. So in a way, our WITS model, any speaker can speak any of the language. Means Bhojpuri speaker can speak English text also, Bengali text also, and Kannada also. So as per the challenge rounds requirement, we need to convert the voice into personalized output, you can say. So we used a FreeVC module, which is basically a one-shot voice conversion. It extracts the speaker's embedding from the reference clip, as well as the neutral speech that came out of WITS model. And it injects the reference clips embedding into the synthesized audio, and the cloning of that audio is happening. So a data set, this was also a good thing about our model, that we used the least amount of data set. Despite English being in the loop, which is not truly phonemic, which is phonemic in nature, we used around English 49 hours of data, which was sufficient for a grapheme-based unified model for English. Rest of the Indian languages said are basically orthophonemic, so we can leverage that advantage. So we can say 30 to 40 hours of data for English is sufficient, means for a decent text-to-speech for English. For other languages, the data is sufficient. And the infrastructure was thankfully provided by CDAC Param Siddhi. We trained our model on NVIDIA A100 GPU, and the total duration of our training was only 1.5 day. So using the grapheme based model, you can this model becomes very simplistic. You can take that speech TTS corpora and just inject it into our training script, and your TTS will be ready. No specialization required for linguistic annotation or phonemization. So this one is the test we did on our test set. That's the male substral distortion score. And you can see here the MCD score for Hindi is 3.97. That means the generated audio is very much almost similar to the ground truth. But that was not in the case of English and Gujarati. Obviously, phonetic mismatch was there, but still 4 to 9 is considered to be a good score in MCD. And in another objective evaluation, we used Whisper ASR for calculating the word error rate, means intelligibility of the synthesized voice was measured using Whisper ASR, and English obviously had stronger support, so 9% was approximately 9% was the word error rate. Marathi had the least support, so we were at 22% of the word error rate. So this can be attributed that Whisper ASR has the little bit support for other Indian languages. Yes, and this speaker similarity means the reference clip that was given to us and the synthesized voice in that. So how much it was similar? So as you can see, almost the cloned voice is 86 to 91% same. So we can say free VC module effectively transferred timbre and prosody. Yes, this is one of the important aspect while means going to a research project to deployment. For that, we did some benchmark testing on a single NVIDIA Quadro RTX 6000 series. This is a very basic GPU with 16 GB RAM. We also wanted to test on RTX 2080, that the beginner level of GPU. So on that, our max throughput was 6 requests per second, and the throughput and the mean latency for concurrent user, you can see here. Is there? Okay. Is up to 8 user making 2 requests in a second. That our this GPU and this machine can and this model can handle 8 into 2, 16 requests without latency. Up to 16 user, you will get a latency of 4 seconds. But I think 8 to 10 users, it can easily cater a concurrent request. So, yeah. So these were the few takeaways of our approach. Unified grapheme vocabulary that makes it phoneme free, and we completely removed the dependency of G2P converters. Zero sort adaptation using free VC, and finally the lightweight architecture, which basically separates the linguistic modeling from speaker style transfer. Future roadmap. So we want to extend it to support dialects and extremely low resource languages, especially from the Northeast region. And obviously, you'll see in the demo also, most of the systems are not expressive. So incorporating emotion and speaking style control directly into the synthesis. Robustness, fine-tuning FreeVC to reduce timbre leakage and handle noisy reference audio. These and the final one, that edge deployment. So far, we have been able to reduce the model size to 70 MB. For Hindi, we have tried out, and now we are trying to incorporate again all the 11 languages into a single model with a total model size of 300 MB. I think that would be good for edge deployment. And yes, one thing that TTS requires is text normalizer. And for Indian languages, we do not have text normalizers, handling of numbers, web expressions, emails. There are so many nuances in there. So we completely rewritten the text normalizer part, and that makes the TTS more smoother. It can speak the numbers, decimals, and everything. So that was all from our side.
Any questions from the audience?
I have one question. In the voice conversion, are you training the voice conversion model also?
No.
So it is the frozen model is what you're using.
Yeah.
So it's basically cascaded setup, right?
Yes, right. So our weights model can work in separate. We have designed it in stage phases. No? Stage 1, stage 2. So stage 2 can be removed. And still the widths model would work with 11 of the speaker's voice. You can interchangeably use it.
So does it work like even if the reference audio that we are giving in the voice conversion, if the reference audio is in a different language and the generated audio is in a different language, so still the speaker can be picked up?
Right. That can be picked
up. And any accent transfer is happening, or just the speaker is getting picked up?
Only the timbre and the tone of the speaker is being captured. Yeah.
Okay, thanks.
I have two questions. One is, you said you have 500 units in your graphene. If you have 11 languages, and it's almost like 50 units per language you're taking, right? So what is the reduction that you've done? Because normally, if you look at Indian languages, total should be 50 units, not more than that. So why did you have 500 units in your system?
You can say, ma'am, time and the effort that would go into making a common level set kind of thing. So we actually didn't do, and obviously the model parameter certainly increased when we increased the parameter to 500. But certainly this is a very good idea, and after this challenge round, we will make a common level set kind of thing and map each language character with a common level.
Yeah, another question that I have is, you said you have a duration predictor. Prosody, does it include only duration, or are there other parameters that you need to worry about?
I didn't get your question, ma'am.
You talk about prosodic transfer. You said there's a which has an inherent duration predictor.
Right.
Is duration the only parameter that is responsible for prosody?
So in prosodic transfer, as far as I know, like only duration is not the thing. Like there are many things like pauses and pitch, all those things. In this model, we are not capturing, we are only capturing the timbre and tone, nothing else.
Yeah, I know one other thing is when you train with multiple languages and if you synthesize for a new language, what will happen is if you give multilingual text, code switch text if you give, it will speak one speaker's voice and another speaker's voice, the other language will come. So how do you hope to address this? It will not give the same voice because after all it's some context vector which is there somewhere. And that context vector is seen in Gujarati, this text. So if in the new text that you have, that phrase is Gujarati, like you speak like a Gujarati voice. If something else is Telugu, like you speak like the Telugu voice.
Yes.
And you see, it's very common. So how do you hope to address these kind of problems that are there?
If it is a totally new language we are talking about, ma'am?
Yeah,
means the model has not seen
that language at all. This is what often happens. Because you claimed that it can work for any new language.
It can work for new language with minimal of training from that language.
How did you do text normalization for English? You converted it to Devanagari or something. What did you do?
No,
kept the script as it is.
So the script as is, but the numbers are handled differently. So different kind of like a URL or an email or a number or a date. So usually in TTS systems, the numbers are not properly pronounced.
No, but there is in Python, there is a package which does number normalization.
Yeah, that is there, but it doesn't work for many Indian languages. It works for English. We have tested.
It works for most Indian languages.
Yes.
You just have to augment that, that's all.
Yeah.
Num2 words is a
is for English.
Yeah. So we thought it will speak 1 million and 10 billion kind of words, right? We wanted it to make.
And you would just augment it for all the languages.
So we wanted it should speak 10 crores, like in Indian style. So that obviously that can be that is usable.
What you are suggesting, like we can augment the same thing, or we already had one number conversion, that's why we use it.
One last question as we have to move to other presentations.
So you mentioned at the end that there is a dedicated one-time normalization task which you have to perform because of the Indian languages, and I totally understand and acknowledge that it is not available. The system is not yet matured. But don't you think that that will act as an overhead with respect to, suppose if I want to take it to a common person as a scalable parameter which can scale to billions of people in India? So even though it is one time, but don't you think that so my question is how lightweight with respect to the compute overhead do you think that your solution is going to be? Suppose if I want to scale it to, because here we are talking about the pregnant, like the underserved pregnant women, the aam admi or the very underserved people, which so we should be really compute less intensive, right?
Yeah.
So
So I'll try to answer this question. So the text normalization which we have uses standard Python libraries. It doesn't it hardly gets computed in milliseconds. So it's not like a model. It's a rule-based system which works well, which doesn't incur so much overhead in terms of computing or time efficiency.
So we were thinking in a code mix text, we want to introduce the context of the, suppose there is a word and written in between of Hindi word, but rest of the text is code mixed with English and Bangla. So we wanted to identify the language there also. So it's another overhead. So, but if it makes the TTS generation more natural or intelligible, then a few milliseconds of overhead can be taken up. Because as I shown, 0.52 was the mean latency. So after before normalization, it was only 0.51. So an additional of 0.1 millisecond was the overhead in the rule-based system that we developed. Thank you.
Thank you, team. Now I would like to invite Immverse AI. So some intro about this company. Immverse AI acts as a bridge between ancient Indian wisdom and modern AI innovation, building an AI ecosystem that connects learning, research, manuscripts, and knowledge dissemination through AI-powered conversation platforms and avatars. The team consists of AI professionals, researchers, developers, building AI and ML solutions. May I now invite the team onto the dais.
Thank you. Thank you. Good afternoon, everyone. So we are team Immverse AI. And like we were just introduced, so basically there is a slide missing. Okay, fine, no problem. All right, so the same introduction, but there was a slide which I guess got lost. So we are working on kind of integrating this ancient Indic wisdom hidden in like manuscripts and integrating it with the modern AI innovation and like making it accessible to the world through conversation platforms as well as like interactive avatars. And so we have built products around that. So things like chat-based conversations and interactive avatars and learning-based platform, which is like AI-powered personal learning. And currently we are also working on domain-specific vertical GPTs for, let's say, healthcare or similar domains. So when I say healthcare, it's like Ayurveda. And for this particular hackathon, so that's our team. I am Pradeep. I am Principal AI at Immverse AI. And Himanshu is VP of Engineering, also a hands-on engineer. I have Pratik and Tushar with me. So they are AI/ML developers and did the heavy lifting for this project. Along with one more member, Pranay, he's like missing here. Right, so starting the problem statement, again, as we know, it's multi-speaker, multilingual TTS for Indian languages, 10 Indian languages along with English, with some additional special feature requirements like ability to do zero-shot voice and style transfer, and like code switching, mixed language input should be handled, and then, of course, efficiency and scalability of the solution, those kind of things. So the approach we decided to go with is, okay, an interesting bit is when we started with the hackathon, that time we were working on a separate model for Sanskrit TTS and trying to deal with the nuances of Sanskrit, but not really gotten into this space of several multiple Indian languages handling through a common model. So here we, given the relatively shorter time frame and also the access to resources that we have, we decided to kind of find the best available resources and kind of leverage it as much as possible and then try to accomplish the goal. So idea was to find a suitable base model that we can work upon, improve upon, and train further for the target languages. Then also integrate the additional features as required for code switching or style transfer and so on. And build like an end-to-end pipeline for this TTS solution. So we selected FI model-based architecture and in turn Indic FI, which is like trained on the same architecture, but trained on some of the Indian languages from our target set. So there are like 6 languages mentioned here. kind of supports the voice transfer already, but we need to extend it to all the languages. And okay, we'll come to the architecture. Does not really support English at all. So yeah, so in brief, I will like to talk about the overall TTS pipeline architecture that we built. Just to go into the little bit details of the model architecture itself, on the right side, the main key TTS block is expanded. So basically it takes 3 inputs, kind of concatenated text from the reference audio as well as the target text, then the MEL spectrogram from the reference audio, and the spectrogram part of the target is kind of masked, and you have entire Gaussian noise representing the starting point for the spectrogram to be generated. And these 3 are concatenated and provided to, so this is basically a flow matching based architecture using diffusion transformer. So the text part is converted into a representation more refined and aligned with the speech part using the connext 2 blocks. And then all the 3 are concatenated and passed to the DIT block. The diffusion transformer will try to predict the vector fields that will allow for the like basically transfer from the noise Gaussian distribution to the target distribution of the data points for the MEL spectrogram that needs to be predicted. And the audio solver then will convert it into the actual MEL spectrogram. And as you can see, I started with this block because there is some nuances. So what we do is, for the style transfer part, the reference audio and text is already kind of included within the context of the model itself. And then it becomes like a conditional flow matching flows and conditioned on the properties of the audio captured in the MEL spectrogram. And in the generated spectrogram also, this part will remain. So we kind of need to trim that out to get just the generation part, and then use a vocoder to convert it into the audio waveform. For this to happen, we need to do some pre-processing steps. So if you look at the block on the left at the bottom, so we get input text and reference audio, but we also need reference text. So we use like Whisper for ASR. But if you look at this, again, there is like a fixed context window. And so basically a fixed number of audio frames that the model will generate at a time, corresponding MEL spectrogram. And part of it will be taken by the reference audio MEL itself. So if the reference audio is too long, kind of, there is not much audio frames left for the target generation, and then the audio could be sped up instead of at a natural pace. So we need to limit that. And the model does not really need much longer reference anyway to capture the properties. So typically 3 to 5 seconds is enough, but the audios during evaluation, they were like more than a minute long. So we introduced a trimming module. What it does is it detects the silence pauses in the reference audio and kind of finds a suitable patch of that audio, about 5 second to 10 second max. And that kind of also takes care of, because of the silent pauses, is kind of independent chunk and not arbitrarily cutting in between. So then text from reference as well as the target text goes through normalization for the currency, dates, and numbers. And then it can move forward to the model, except it kind of works for the phonemic languages, so typically English languages. And the tokenization is like character level tokenization, so there's a vocab for the Indian language characters, but doesn't work on the Roman script. It's not really phonemic. So we do 2 things. One is transliteration, which is from English to Devanagari. And after that, then the model can work well. But there could be sometimes some errors in the transliteration, or some words are peculiar that it may not handle. Plus, primarily, for example, in this particular use case, there is this medical scientific domain, and that has many terms which TTS models typically may not be able to handle. Even the data set usually don't contain those kind of terms. So we have a lexicon mapping kind of model in between, which takes this all domain-specific terms in English and again maps them to also to their Devanagari more phonetic kind of version. So then the model is able to handle them better in 2 cases. One is English, another is the mixed language kind of thing, where it could be any language, but the scientific terms will be in English. Yeah, And after all that pre-processing, then the model flow is same. Yeah, the same pipeline is kind of explained here. Okay, so challenges also I think I briefly mentioned. So first was there were only few languages supported, so we had to train on the entire CISPIN and SPICOR dataset to add the support for rest of the languages. But English, again, is peculiar. For that, just fine-tuning further is not helpful. So for that, we added this transliteration as well as the lexicon mapping kind of models. And yeah, that's here. Other than that, reference audio constant also I mentioned. So we tried two things. One is properly trimming it around the silent pauses, as well as another thing we tried was denoising, but that kind of takes a lot more longer. So in the final version, the denoising part is kind of left out, need to be worked further upon. This is because it is directly conditioned on the reference audio, so the quality of the reference audio also matters. I mean, it might generate something similar. For noisy, it will generate noisy, but it's better if the audio is clean. Then, yeah, normalization part I touched upon for units and currencies, numbers or symbols. And right, reference text delimitation, the thing is because we are concatenating reference followed by the target text for which we need to generate the audio. That kind of goes together to the model, and it's like one person saying the whole thing. So voice, style, everything will remain same, but the reference audio and corresponding text could be out of context, something else. So we need to purposefully add some delimiters to separate them out so that the model can still generate the target part cleanly. Training details. So on the GPU side, basically we used this cluster of 800 GPUs for 3 days. So we booked on AWS, and the main training was ran on this particular setup. Other than this, we ran many experiments and like slower training runs on a L40S GPU, which we had access to. Data is primarily the CISPIN and SPICOR. Along with that, we added some open source datasets for Indian English accent, and 400,000 plus training steps, and yeah, so some hyperparameters that we basically use the L40S to tune. Batch size, yeah, that is also another interesting bit. So we tried to decide the batch size using the audio samples, but some samples could be much longer or shorter, and then it will basically go out of memory, out of the CUDA VRAM OM issues. So then we decided to basically select the audio frames because that kind of is fixed, and that allowed us to efficiently use the GPUs during training. On the evaluation side, so we did all the metrics as expected in the report as well. I'm showing here the MOS and word and character error rates. For MOS, so we took help from the native language speakers that we knew of and provided them with the access to like the reference audio, reference text, the generated audio text for which the audio to be generated, and some guidelines on how to basically score 1 to 5, and that is where we kind of to get a feel of subjectively how the generated audio sounds like. WERCR, for that we just use again Whisper for ASR, and computed this using the standard packages. There were some issues like earlier also mentioned by the team for transcribing using ASR, Whisper, but also if the input has like code switching, mixed language, or because of the some like part of the text is or one of the text pairs was normalized and others not. Those kind of issues were there. We kind of realized it late, so we haven't redone the WERCR computation. So there are many things to be improved. So some of them are mentioned here. So on the reference audio side, because we are directly using it for conditioning, that helps to capture the characteristics of the reference very well. But then also there is a lot of dependency on that. So we need to ensure like removal of background noise or robustly trimming the audio to the desired length. There is also normalization works well, but in some context, we were facing issues, so that is also something to be improved. For ASR, we are just using faster whisper, which takes more VRAM than our model. So we need like more efficient and probably India-specific ASR, Indian language-specific ASR models as well. Punctuation is interesting bit that we figured out. So if you just provide the text without any punctuation, then it will speak it normally. But if you add like commas and delimiters properly, then it does the pauses properly or exclamation and those kind of things. So because that was part of the training text as well. So in case the provided text doesn't have it, automatically inserting punctuation is also something that helps. It's not automatic right now, but we tried with manually inserting the punctuation. Streaming TTS part also something we haven't implemented in the version that we have here right now. But that is something we have worked on before for other models. So that we plan to do. And yeah, model optimization. So currently it's just PyTorch, for example, version format of said model. So we need better compression as well. And there are things like Onyx and TensorRT that we need to look into. One more thing is the speed control. That is something we already tried. It's possible in the model, configurable. That way, given the reference audio and characteristic, but we should be able to also like speed it up or make it slow down. But that's not yet implemented, but something we have already explored. So that is we plan to do. Okay, so there is a demo URL if we want to see, or you want to just can we? No, later. After. Oh. So I guess we can check it later as well. Thank you. Thanks.
So just want to understand the contributions, if I understand correctly. So you took a model that already supports a few Indian languages, and you trained it on the ones that it doesn't support, right?
Right.
And then you also did the transliteration from English to Devanagari so that you can support English as well in the same sort of framework. And then the text normalization bit that you added, and also the evaluation part, right? So that's essentially, so architecturally, was there anything that you did that was different from what was already supported?
No, the core TTS block that we had on the right, that is same as FI architecture. Right. And only the pre-processing, post-processing bit, that is where we have done the modifications and the training part.
You talked about better ASR will help for Indian language. Can you explain why?
So basically, in this particular,
what are the characteristic differences? See, Whisper is primarily built with 49% of English.
Okay, so in this context, what I meant is like we are running Whisper. It works for the languages. It consumes like 3 GB plus VRAM. And our model takes much less, like around 2 GB. So that's like additional VRAM if you want to do. And its use is only to get the text for the reference audio.
No, I'm asking you something other than that. For English, for example, the grammatical structure of sentences follows a particular form.
Yeah.
Whereas Indian languages follow a different form.
Right.
And so the language model, for example, would struggle. So can you tell me what that difference is?
Okay, how will it struggle for Indian languages?
I'm asking you, what is the grammatical structure for English versus Indian languages? Because there is a language model which is embedded in the Whisper model, right?
Yeah.
So it could struggle because it's trained with 49% of data from English.
Right.
Tell me what is the difference, at least do you understand it? I want to understand.
I'm not sure very specifically, but so Indian languages have like their own this matras and variation of the characters.
Markers are there in every language.
No, compared to English, for example. Okay. So I'm not sure then. Yeah. English versus Indian languages.
Studied it in school, subject, verb, object, subject, object, verb.
Yeah, yeah.
So that is the fundamental reason why it will struggle. So you're using a square nut and a round bolt.
Okay. Thank you.
Thank you, team. Now I would like to invite Somya.ai. Somya.ai team is led by Vedpal Jangir, who holds masters in AI from IISc, and Rajates. This team is leveraging their deep research background, specializing in building advanced AI solutions for Indian languages, including zero-shot text-to-speech models to ensure voice technology is accessible to diverse linguistic communities.
Notice you can notice. Yes. Okay. Hi everyone. I'm Ved. I'm Vedpal Jangir, and he's Rajat. We both are previously in IISc as research scientists. Sorry. Not mine. Okay, this is our problem statement. We took from here. So we have to build a multi-language TTS synthesis model, and the focus on efficiency, scalability, and reliability. Plus our adoption was I reformulated the entire problem as an autoregressive token prediction models. So it can be adapt to any other languages easily. And plus it can stream in real time also, and there are other optimization also there. So here are our objective to build this one. So first one is a multi-language speaker. So the current LLM paradigm is they are heavily pre-trained and already is there. So we thought we build on top of that because we are heavily resource constrained. So we took a already pre-trained semantic tokenizer, speech LLM tokenizer model, and then a bytecode tokenizer. Second objective was a zero-shot cloning. So earlier in round one, we did single stream token, and the constraint was you have to do the zero-shot cloning for accent and style transfer, as this one was the metrics for that. And third one was the efficient deployment. It can be deployable into any small models, like in a laptop and mobiles also is there. So that's also is there. Okay, this is our solution. Okay, this is something weird. Okay, so this was our solution, a token autoregressive problems, like a token-based prediction models. We did a tokenizer of bicodec, and then we formulate the entire problem as an autoregressive token prediction problem. So it will solve kind of problems like you don't have to rely on all the heavy rule-based language modeling, and you can take a pre-trained codec model that can tokenize the semantic and linguistic part and then put into the model, and that small model can regressively predict the next token, so it can be adapted in any languages, like for similar small dialect or their regional language with pretty less data, because the heavy pre-training is already there. For zero-shot cloning, we did earlier we did the single stream tokenization. Like in single stream, it will produce the semantic and voice tokens. But in this time, we separate both of them. So global token, audio and sound, like a speaker can speak multiple languages, but their sound is similar. So that will do the global token. And you can took a variable, either variable or either context constant. So we did constant part of fixed length. And semantic token can be variable that key, how much user want to speak that. This is the context. And that will solve the gradient context prompt context window exploding problems. Like earlier in F1, we also thought that, but so you don't have to like rely on, like if you give a 30-second audio as a reference, then model automatically capture the 32 token because it's a pre-trained, and then do a conditional based on the semantic token part, like how it produced the semantic tokens and all that. And we did actually, in novelty, you can say we took a Quen 3.5 5 billion parameter model, and then we extend this model for our Indian languages. You just need a embeddings layer on top of the model and then stabilize the embeddings layer. And you can have to just 1 or 2 hour full warm-up training, and then you can, in phase 2, you can do a full fine-tuning, then it will completely stable, and then do a, for Indian accents and Indian languages also is there. This is the system architecture we propose. So these above are the global tokenization, and it will took from reference audio. So what it will do pre-compiled. Like when you give this reference audio and the text, in loading part itself, it solves the semantic and globalization tokenization in encoder part. And then model only left to predict the semantic tokens also. It don't have to do the audio loss function and all that. So this objective was too simple just to predict the semantic tokens. This is for referencing part. So it will pre-compile the globalization as a speaker part, and then predict the token, and then detokenize with the same tokenizer. Our evaluation is like we don't have proper evaluation suite. We use indic transliteration for text normalization, and I think from AI for Bharat, there are pretty good ASR models, the 600 MB models, pretty smart models. We did use that for ASR modeling, and these for MOS score we did in lab, collect the mean opinion score. The deployment efficiency is like 0.5 billion parameters, so it's much smaller model and can be deployable anywhere, and it can be deployable in a laptop with 4 GB VRAM. And plus one more thing is for like adaptability and scalability, like you don't need anytime 20 to 30 languages in a single model. You need one model with one small precise model with single dialect and single language. So you can, from this base model, you can distill it into a single dialect and single language model, and can adapt in anybody. And it can train, our entire model can was trained on like single 800 GPU with like 8 or 10 hour entirety. So that's also there. Okay, these were the failed experiment, I can say. We did lot of experiment before come up with these results. I did in first round I did that part, Llama 3 model, base model, and single codec, snake codec. So that was the objective in previous round. It will condition the reference audio and then predict the audio based on that part. But what it will do, it will took the reference audio in a condition part and expand the window size. So if you have like 30-second reference video, then there is no chance to predict next audio token. So that's a problem. And second, the size itself, it's a 3 billion parameter model, so it will training and all that, it will complex. And third was there is zero-shot cloning, it's not stabilized either, so that's also a problem. In second iteration, for zero-shot cloning hack, I took randomly 3 to 6 seconds and preconditioned the objective, and then did the same, but results are almost similar. These are conclusions, like, yeah, these are same, whatever I explained you earlier. Thank you. Okay, if you have any questions, sir.
Can you show the architecture slide? Sorry. This one. Yeah. So actually, when we talk about the edge device, right? So because we are talking about pregnant women, they are very low resource devices. So when you talk about the codec encoder, right, and then finally you are using the speech LLM here, and then again the bicoder decoder, the decoder on the top of it, right? So my question is like, suppose if we and I think the parameter is 0.5 billion, right? So
yes.
Suppose if we want to execute as a SLM, like a very short language, a very small language model on an edge device, and it's a low resource, so the internet is also very low, right? So you can't host it on, like, so my question is whether you want to host it on cloud, where each transaction, each call, each query will go to a server and then fetch the response, or you want to execute it completely on edge, on device. But you will have to keep in mind that these are pregnant women, these are from underserved communities, so they won't be having a posh mobile with heavy RAM and compute power. But at the same time, if for every query, if the query is going to a server and then fetching the response, that is also bad because the internet is not there in deep root villages. So how are you going to solve the problem of whether you want to host the complete model, the complete the text TTS model on the device versus on a cloud instance, but then at the same time you will have to worry about the internet cost. So yeah.
Okay. Sorry. I missed a lot of things. First, the model latency or model inferencing speed is, the real-time factor is 0.42. So it can, if in a 8 GB of GPU RAM memory, it can produce 100 seconds of audio in 42 seconds. But it can go real time on CPU basis also. You don't need GPU for that because the model is too small and can fit into a RAM also. Second part is the internet and all that. You can we did with VLLM deployment, so you don't need to rely on internet or anything. You just build. You can deploy easily on edge devices. Plus, we actually did a lot of optimization. Like the model footprint are very low if you do the quantization and or other optimization. We didn't train on FT32. We did on F16 or BF16, and because int 4 or int 8 they are unstabilized the training, so that's not good. But and also there is a flash attention module for training. Optimization is good, but really not good for inferencing. So that's also a problem. But you can put in any edge devices and it will do great. For training part, you need server, like with a single GPU, 8 GB GPU will be fine, or 16 GPU will be great, and it can adapt any local dialect or local language in like 3 to 4 hour data and can go, because the embeddings layer added into the top of the pre-trained model, they need to stabilize, and then you can do, it's already 0.5 model, and you can train LoRa on top of that part. Initially, when we started this one, I thought of F5, Indica 5, as you guys did. But the point is, it's a diffusion-based model. You can't do LoRa training on that. So it's adaptability problem was there. So I completely scrapped that part.
But you need to consider the fact that their mobile phones are not like up to the mark. So when you talk about even 0.5, forget about 0.1 billion parameters also. I don't think it's going to solve the purpose, right? Because and many of them would have feature phones stuff, right? So I don't think it's going to solve the purpose. Like,
okay, two things more I address. First thing, at least you need a laptop. 4 GB RAM you need at least if you want to do the speeding and all that. But if you want to really go for edge devices, you need distillate model take this model as a base and then go distillate model. That can be like 50 MB to 100 MB for specific dialect and specific language, not the entire 22 languages. I mentioned that, but probably. And second part is, okay, I select speech LLM because the application point of view. Let's say we don't want text to speech only. In voice bot or chat bot, there needs to be intelligence that not only produce text and then speech. The LLM itself can be trained on your user data and then can come back with you answers, not the just text speech part. that's why I use LLM, because application-wise, it was be much more efficient because it's already pre-trained, so we don't need to do the heavy pre-training lifting. So you can easily switch the LLMs and then it will produce the same result, because you just need to convert the text into phonetic tokenizer and then produce the actual answer into text part. So speech-to-speech model also it will be efficient if we put ASR, two layer of ASR model, as AI for Bharat provide very efficient model for that. And second is normalization also is there, because I mentioned to forgot, there is a Indic transliteration library and num to num library for Indic languages specifically. They built a very good library, so that will solve the translation problem. So domain specific issue won't be there if you do that part.
Yeah, but if you're using AI for Bharat's transliteration model, that is some 63% accuracy. Accuracy is not very high. Another thing is my question is, this Quen 2.5 which you talked about, it's a speech-to-speech LLM, right?
No, it's not speech. It's just a, you can say transformer-based model that will produce the semantic tokens, not speech tokens. They're like content that represented into text represented into how to speak.
Somebody must tell it what that semantic content is, right, for training. So where did you get that?
Bycodec tokenizer. We did that.
So what is bycodec?
Bycodec is like a neural tokenizer that will produce two type of tokens. It's global sound tokens and the content tokens as a semantic tokens.
Yeah, I'm asking you to train the bycodec, right? Or
We
did you not train?
No, we took pre-train.
If you took pre-trained, on what languages was it trained?
English. Sorry.
So then?
We stabilize for our Indic languages to expand the embeddings.
What do you mean by stabilized?
Because if we extend the model size, then
I'm asking you, what do you mean by stability of a model?
Fine-tune the embeddings layer of model on Indic languages.
How much text did you take for that?
Entire data sets. It will take like 4 hours to stabilize only 30% of model, and the entire fine-tuning will take another 8 to 10 hour data on single A100 GPU.
Okay, you said you brought it down to 0.5 billion parameters.
Yes.
What are the criteria that you use to bring it down to 0.5 billion?
It's subjective kind of. We did the testing part. If the model can be good with lower parameter, then we didn't train for higher parameters. So from lower to upper, we did part. And these were the initial results. We are trying to bring down the also, but. Thank you.
Thank you, team.
Murli. Now I would like to invite team LTRC. So they team with 8 years of leadership experience in machine learning and data analytics. This team specializes in high fidelity speech-to-speech translation. The team has successfully deployed TTS models for Ministry of Tribal Affairs. They work in preserving low resource languages including Santali, Mundari, Bili and Gondi, marks them as experts in applying cutting edge ML to diverse linguistic languages.
go back. Good afternoon, everyone. So we'll be presenting our work, Multi-Accent Neural TTS for Low-Resource Indian Languages. So here are the contents of our presentation: introduction, methodology, dataset, TTS model details, evaluation techniques, sample outputs, conclusion, and references. So the main objective of this work was to develop a robust multilingual voice cloning TTS model for 11 Indian languages to bridge the gap for low resource languages and to build a lightweight, efficient TTS models that supports voice cloning, and it's compact in size in MBs for deployment on real-time applications. So this is our overall methodology. The multilingual speech text dataset provided to us were the CSPIN and Spiker dataset. Along with that, we included Indic TTS and Indic Voices corpus. And so there were total 11 languages and 35 domains. Out of that, we sampled and filtered few of the domains in round 1 and round 2, and then used the IMS token TTS base model and fine-tuned that model based on the sample dataset, and then perform the speech quality evaluation. So first of all, we'll come to the dataset distribution. You can first set of the columns represent the CSPIN Spiker dataset, and the second one are Indic Voices and Indic TTS. So considering that this is meant for healthcare domain, we selected out of the 35 domains present in CSPIN and Spiker, we selected food, health, agriculture, and regular conversations, and formed the sampled set of corpus. And in order, also CSPIN and Spiker has only one male and one female speaker. So we also included multiple speakers from Indic Voices and Indic TTS for the languages which they support. And we formed the total corpus of 621 hours for all the 11 languages. The overview of the architecture. So we have a reference audio, a language ID, and the text. The text is converted to phonemes, and then from the phonemes, we extract articulatory features of 64 dimensions. And from the reference audio, we extract the speaker embeddings. And from the language embeddings, we concatenate all three of them, pass it through the encoder network. And the encoder network is next passed through a variance adapter, which actually predicts the pitch, energy, and duration of the phonemes, which is then converted to a MEL spectrogram using the decoder network, and the MEL spectrogram gets converted to speech using high-FIGAN vocoder. So the first step of the model was the data preparation. So in the data preparation, first thing was to convert the text and normalize the text. So if we can have digits, we can have code mix text. So we use eSpeak-NG phonemizer for converting the entire text into phonemes. Now, there are 4 languages which are not supported in the eSpeak-NG phonemizer. For that, what we do is we convert the numbers into num2 words, and then convert that into the script of Devanagari, and then pass it through transphone. Transphone supports the other 4 languages, and then ultimately the entire text is converted to phonemes. So those phonemes after that are pre-processed to get the 64-dimension articulatory features. So these articulatory features signify if they are voiced or unvoiced, if it's a vowel or a consonant, the position of the tongue, it's a labial or a dental voice. So all of this are represented in form of a 0-1 binary format of dimension 64. And next we have the audio files, which are now converted to MEL spectrogram. And we also have an aligner, which will give us the timestamps of each phoneme and the duration of that phoneme in the entire, of all the audios in the corpus. So, and also we have the speaker embeddings using the eKappa TDNN model. So these are all our pre-processing steps. So ultimately we have a speaker embedding, we have language embedding, we have the phonemes and their articulatory features, and also ground truth, pitch, energy, and duration. So for training the model, once the text is converted to the phonemes, we are passing those hidden representation to variance adapter, which can convert the phonemes or the representation into frames of each frame, and then those frames will correspond to a particular pitch, energy, and then with the help of a length regulator, we will decide how many frames correspond to how many phonemes in the speech, and then convert that into a preliminary spectrogram or the MEL spectrogram. And then we'll convert that MEL spectrogram. It can be either refined or not refined. It's an optional step using a conditional flow matching decoder. So this was our training architecture. For inference, we have the text to phoneme, phoneme to MEL, and then MEL is converted to audio with the help of hi-fi. For evaluation strategies, we are using these 5 metrics: word error rate, character error rate, real-time factor, mean opinion score, and speaker similarity score. So these are our outcomes. So we can see it's for speaker similarity, we used WaveLM SV embeddings and computed the cosine similarity. For RTF, we are getting good scores for the first 7. The last 4, the RTF is a bit high. And similar for the Morse code as well. However, it works fine with the speaker embeddings. And so here are some sample outputs if you want to listen. And so these are the main outcomes of our work. So it has reported good Morse scores for Hindi and Telugu, and it maintains good speaker similarity, and also it is having a less real-time factor.
Can we open it?
For sample audios?
Interesting that you mentioned using articulatory features, which I haven't heard about for quite some time. So do you think that that made a difference in the ultimate output? What were your motivations for using that?
Because we have the, so many of the languages are using the same script, Devanagari script. So converting them, instead of treating them as different tokens, if we can convert all of them into just how it is pronounced, if it's a vowel or a consonant, voiced or unvoiced. So it would lead us to a common space instead of having multiple tokens, or even if the same character being encoded multiple times for all the languages. Yes. Yeah.
You also have to use the place of articulation and manner of articulation.
Right.
manner of articulation, you're saying, okay, you'll do voiced and voiced. What about place of articulation? You talked about bilabial and things like that. Indian languages have affricates.
Right.
So that's, in fact, that's one thing which doesn't get spoken properly at all. So how did you give these articulatory? What is that 64 dimension in your?
Yeah, we can show that. We'll have, so we had a 64 list of dimensions. We can open that.
Now, does it correspond to actually articulatory?
Yes,
movement?
it corresponds to sound units like consonant, affricates, bilabial, fricatives, etc. So, sorry?
Where do you get that list from?
So it was already available in the 64 list of articulatory features. Can you open that link?
Okay, another question. The toucan, did you take a pre-trained model, or
Yes.
did you train from full start?
No, we took a pre-trained model.
What was it pre-trained on?
So it was pre-trained on 7,000 languages, including Indian and European and many other languages. Like it was trained on 462 high resource languages, and remaining were all low resource.
Did you do, as you said, some ablation studies to check without articulatory features, how did it perform? So how did you give these articulatory features? Because this is new, right? You're giving it, or toucan already has a facility to give articulatory features?
It has the facility to give,
Oh, so
and
the
it has.
64 parameters are from toucan.
Yes. Yes, ma'am. These are the ones. So for every phoneme, it has those features. So that's the last two are the place of articulation and the manner of articulation. Then we have the position of the tongue as vowel frontness, and others are voiced, unvoiced.
Is this adequate for something like Bengali, which has 3 different A's, no? Did you check it? You're a Bengali, no?
Yes.
So what you write, for example, you write one single A, but it
Right, yeah.
does it take care of all of that? Or
Not
did you-
always.
Not always.
Not
means what do you
always.
mean? Did you try to see how to augment
So
this?
I just tested with my name. It is supposed to be pronounced as Onindita, but it said something else, Unindita. So we have O and O for the same representation, and it's not really rule based. We don't have a rule when we will say O and O, but in this case it was not always.
There must be a rule, no? You could have processed it and given it, no?
Yeah.
So taking something off the desktop and not fixing it for Indian language is not a great idea, right? How do you take care of vowel and all that?
Excuse me. I have a question. So these articulatory labels are text-based, right?
Right.
So when you have all this data set, but the thing is, sometimes pronunciation and whatever phoneme, they don't match because of accents and other things, right? So ideally, wouldn't it be better to have some kind of setup that predicts this tokens, articulatory labels or tokens based on acoustic features than text itself? Because I work with articulated trajectories and stuff, so usually phonemes, whatever you get, are not usually what they have pronounced.
Right.
That happens a lot when you have articulatory features which are based on phonemes. So don't you think that would have benefited a model like this better than just using text-based?
Okay, so apart from only using the text-based articulatory features, we are concatenating them with the speech features and then predicting the pitch, duration, and energy. So,
I'm sorry, can you repeat that?
So we are using the ground truth, pitch, energy, and duration to be predicted from these articulatory features for constructing the MEL spectrogram. So this is our starting point when our text is converted to these features and then passed to the transformer encoders.
But usually it's not pitch and energy, right? If you think about accents and articulatory features, it's usually position of tongue, lips, and these things. So
right.
Ideally, wouldn't you want to have like these labels predicted from, let's say, if you have this reference audio, right? If you predict these kind of features using the reference audio, it's just an example,
right.
use those in some kind of embedding to condition the model so that whatever the model produces, the audio, will have that kind of accent in the predicted audio.
Okay, so you're asking instead of using the eKappa TDNN for the speaker, instead of using the speaker.
In addition to that, you could use.
Okay, yeah, we could have done that.
ఈసారి కూడా జూన్ 21.
So we are playing one sample. So this is a reference audio.
తేదీన మన దేశంతో పాటు ప్రపంచం నలుమూలల.
So this is a reference audio, and this is a sentence.
Hello. Hi. So, yeah, you told that you took a pre-trained model and you then fine-tuned on other languages.
Yes.
So my question is, when you train the model for the first language, then you go to second language and third and fourth, so on. So does the acoustic information carried out from the first point to the last final output? If yes, then how do you tackle this issue? And if no, that how this happens?
Okay, so the pre-trained model which we have taken, it supports almost 7,000 languages. So because it has some language embedding space, so with that, so it supports 7,000 languages. So that's why we have taken that, and on top of that, we have fine-tuned it.
And the fine-tuning is not sequential, like it's not that we fine-tune the pre-trained model on English and then fine-tune it on Hindi. We are fine-tuning the whole thing on 600 hours of 11 languages data.
So you fine-tuned separately?
No, we did not.
Then?
So the single model supports all the languages. So we fine-tuned on top of that. So it's not like we are adapting any language.
Oh, okay.
Train on one and then follow with the next one.
Okay.
Then the phonemes of one language will get carried to another.
Okay.
Or did you randomize the entire input and do it?
Yes, we randomized, ma'am. So we randomized the entire input.
You put all languages you randomized?
Yes. So I'll just play some audios. So I'll play the reference audio again. So this we have.
ఈసారి కూడా జూన్ 21వ తేదీన మన దేశంతో పాటు.
So this is in Telugu reference audio, and this is the text which we try to synthesize, and this is the.
అనీమియా అనేది ఒక పరిస్థితి. ఇందులో ఎరుపు రక్త కణాల సంఖ్య లేదా వాటి ఆక్సిజన్ రవాణా సామర్థ్యం శరీరపు అవసరాలను తీర్చడానికి తగినంతగా ఉండదు.
So this is the synthesized audio. There are scenarios where things are failing, but yeah. These are in the reference audio is in Telugu only. For example, we have Bhojpuri and other languages as well. I'll play one Hindi.
आपको याद है 10 साल पहले इसका प्रारंभ हुआ.
So this is a reference audio.
नीलम रोज शाम को जंगल के पास जाती थी.
Primarily because alignments are poor, especially for fricatives. Affricates, for example, you always have this problem. So that's something that's worthwhile looking at. You have an aligner, no? You used a CTC aligner, I think.
Yeah, we have an aligner to predict the timestamps of the phonemes.
So please check, go back and look at the spectrogram.
Okay.
You'll know what mistakes it's made.
Thank you.
Thank you all the teams for the wonderful presentations. Now we'll break for high tea. In parallel, the jury will also evaluate all the audio samples from all the teams. We request participants to please remain available in this floor in case jury has any questions to ask. Yeah, and then now after the high tea, we'll again reconvene at 4:45, and we have again ecosystem talks from Amitabh Nag, CEO Bhashini. Thank you. The high tea is arranged in the same floor terrace. We'll be starting in 5 minutes. Welcome back, everyone. As we move towards the closing segment of the day, we are honored to hear from the leaders who are shaping India's voice AI ecosystem at the national level. Now it's my pleasure to invite Mr. Amitabh Nag, CEO, Digital India Bajni Division, our chief guest today to share his perspectives on the voice technology ecosystem in India.
Thank you very much, and good to be part of it. Although I am in a rush, and although I wanted to be with the team in the morning, I could land up at this point in time, and also, I'd missed multiple discussion which we are having. So we am today at Jammu having a workshop with the state government to, increase the data corpus for Dogri and Kashmiri languages, as well as looking at some other languages which are local to this place. So it will be quite an interesting phase because we have almost touched base with 21 and 22nd state now. There are 6 or 7 states which are in pipeline to sign off very soon. They are going to be also part of our ecosystem. And those ecosystems actually will work upon building this, voice AI system, and will take this forward. So thank you very much for being part of this revolution. But all of us should be, looking at how do we encourage, people to contribute data? How do we build those narrow use cases which are there? And how do we strive towards better accuracy, better portfolio, better things which are around today? So this hackathon was one such, event in that direction, while as there would be other use cases which we all have to work upon. So thank you very much for having me here, Partha, but at this particular short notice, as well as adjusting to the times which have been quite engaging for me here, because we had planned this workshop for a very long time. So I couldn't be there in Bangalore. And also in the morning, there was a inaugural ceremony where Honorable Minister was there, so I couldn't be part of it. But having said that, let's strive for something which is very great and better. Both GIZ and Partha and IISc have been working very hard on this collection of data, which is the oil for all AI models. And we hope that the young minds in the hackathons would result into a considerable improvement in the models as well as accuracy. Thank you very much for having me here, and all the best.
Thank you, sir, for joining us in such a short notice. I think now, to complete this arc, we now move on to an equally important question. How do we measure inclusion in speech AI? Now, it's my pleasure to invite Mr. Raghu Dharmaraju, CEO of ArtPark, to speak on what do we actually measure to call speech AI inclusive.
Hi, everyone. Can you hear me? Yes, no? End of the day, don't care, right? So, hi, everyone. My name is Raghu. I'm CEO of ArtPark. ArtPark stands for AI and Robotics Technology Park. We are a nonprofit created by the Indian Institute of Science, and we work with many partners in essentially creating technologies that are actually useful for society and economy. So we say we are at heart venture builders, and ventures are of both for-profit and non-profit in nature. And one partnership that has really made it very meaningful for us to work in this space has been to work with Professor Prashanta Ghosh here. I don't know where Prashanta is. Maybe he's out. But I really want to give a shout out, because without him, we wouldn't have gotten started in the voice tech space at all. For me, the motivation was very simple, right? I've been working in the tech for social good space now 15, 16 years. And what struck me from the very beginning is that the failure of most tech seemed to come down to unfriendly design. Right? How many of you experience unfriendly design every day? I'm surprised. Are you folks from Bangalore or somewhere else? which roads are you on, right? So see, we experience unfriendly design everywhere, right? Examples of unfriendly design: you have soapy hands, you're trying to turn the knob is round. You can do whatever you want, right? But it's not going to turn. I mean, it's not generally about Bangalore. I should not point out Bangalore, but generally we experience unfriendly road and pavement design every day, right? And that's what impedes our ability. Why do you not go out to eat as much and order in instead, right? In some sense, it's the frictionful experience of getting out there that is stopping you from going and actually dining out with your friends or family, where you are instead going to sit in your room and impinge the inconvenience on someone else for hopefully not that much price, right? The gig workers. Now, the thing that struck me with lots of apps that were launched, that were beginning to get launched back in 2010 onwards, right? We started seeing the first smartphones 2007 onwards or so, right? And then there were feature phones. And to me, the graveyard of apps, as I especially worked quite a bit in health, graveyard of apps came down to this unfriendly, unempathetic, right? Perhaps lazy design. Right? And the biggest part of all this was this whole experience of typing. How many of you like typing on your phones? You like typing on your phone? No, I'm only partly judging you, right? Right. Actually, none of us are natural typers on a phone, right? We might type on a laptop, right? But we don't type on a phone. And what if you are not digital natives like you and me, right? You are more of a digital native than I was. I first ran into a computer in my undergrad, right? Before that, I had not touched a computer, right? So, but you are digital natives, but there are folks who have not touched a computer in their life, right? If you go to my mother and give her a laptop, she's going to be all lost. She's already lost on her phone, even with Telugu interfaces and all that, right? So this is really fundamentally what inclusivity comes down to. Right? You have digital, you want digital India, you want Viksit Bharat, you want an inclusive India. It cannot happen without natural interfaces. And voice tech is really at the core of that, right? And health is the most difficult one. How many of you have ever been in some argument over outcomes versus outputs in some technology solution? Okay, one hand. Okay, Sunaina, of course, right? You have at some point. So outcomes, what are health outcomes? Give me some examples of a health outcome. Okay, you take a medicine, you get better. That's a health outcome. Is that fair? Right? So that's a health. That's a very physical thing, right? You have something, you get better. So health outcomes are typically measured in what are called DALYs and QALYs. Ever heard the term? Disability adjusted life years, quality adjusted life years. Mota moti, what that means is everything can be measured as some change, some positive or negative in your quality of life is essentially what it means, right? So let's say I live to 100, but let's say I am from 80 to 100, I am entirely bedridden. Those 20 years are really not going to count for quality of life, right? So outcomes are at that level in health, right? And that's how they are measured. So if you take a medicine, you get better in, let's say, instead of 5 days by yourself, versus you took the medicine and you got better in 2 days, right? Those 2 days are what you attribute to that. The additional, 3 minus 2, 5 minus 2, 3 days, right? That's what is really the incremental benefit of that. Now, if you take tech, right, you say you are going to do this voice thing, and then you're going to, how do you now quantify how much impact you've really had? Very tough, right? So you end up measuring things in between. Right? So for example, a medical device company that I had helped build was about preventing hypothermia in babies. Right? Really, we wanted to hit infant mortality rate, but we knew that if we were to keep babies at a certain temperature, automatically infant mortality rate comes and those numbers are there. So a lot of voice tech is about access, right? Access and to know that. But you need to be able to measure, right, that the actions after the voice tech are happening, that the voice tech is giving the right information that is actually actionable, working backwards, that whatever core models you are using have the right knowledge and context, right, to take the inputs, and the inputs are understood, right? These are all different evaluations that have to be done. I'm not the scientist here. You have lots of scientists here who can measure that. But one thing I would really suggest that you do generally when you put out there is do at least the smallest real field pilots. Maybe it's just 5 users, 10 users. Makes a huge difference, right? It's how many of you, what languages were we looking at today? Or what regions were we looking at? We were broadly looking at Hindi? No. All Indic languages. About 11 Indic languages. The trick of those Indic languages will be that they work in some place a little far from the metros, right? That they work in places that, and to me, going in with your design research team early on and understanding that makes a huge difference, right? How many of you here have worked with design researchers as part of your team? Okay, few hands. This is another thing I would very highly recommend. This, you might see it as qualitative research as opposed to what quantitative research, that quantitative metrics that you're used to. But I have found that at least in early stages, working with design researchers has a huge impact on what you ultimately build. Design research is essentially, I think of a collection of methodologies which help you understand your users very well, right? When we were first working with Arman, before we built any models, right, we did this kind of user research. For example, Wizard of Oz. Any of you heard of Wizard of Oz experiments? So building AI is tough, expensive, time-consuming, etc., right? So what we said is, how about we get few humans to pretend to be AI and behave in a certain way in response to queries that are coming from frontline health workers. And we'll see how they also interact with this pseudo bot. Through that, we learned various behaviors. We learned behaviors that we should have expected but still surprised us, such as if the persona of the bot is female, the frontline health workers communicated more freely, as opposed to if a bot was male. Right? It's a bot, right? But those things matter. We are humans at the end of the day, right? And we are a product of the experiences, right, good and bad, of our entire life, right? So if you've been, and as a culture in India, it's still very much a male-dominant society, and especially male figures are there especially in positions of authority. It's mostly male figures, right? And here you want a frontline health workers to communicate freely about high-risk pregnancies and many sensitive issues that are in there with a male figure. It might not happen, right? Those things matter. We also found out how they make spelling mistakes, Telugu written. These were some early work we did in Telangana. How Telugu was written in English, English was written in Telugu. There were spelling mistakes all the way around. And still somehow as humans we understood it, but the bots didn't, right? So I would say it's really a progression. So starting from the way I typically think of it is first understand what constitutes success for your beneficiaries and users. Work backwards to understanding what you need to build, that involves not immediately measuring word error rates or or something like that, but it's really about first understanding what the users want and then working from there regarding what's the tech stack you need to build. In the tech stack, you can figure out whether the inputs are being properly understood, whether the knowledge is there to respond, and whether those responses are being synthesized in a way that are useful, and ultimately whether the actions are being taken on the output that's given by AI, right? That's also quite important. Because otherwise, then what the hell? If you say, go take this medicine, that medicine is not available. Sorry, no award for making great voice tech, right? I know we are ultimately technologists, but what I hope you will do is engage with the problem you're trying to solve really deeply, and then ask what technologies you need to bring together, right? So that would be my single message, and thanks, of course, to the organizers here and all of you for participating in this hackathon. Hopefully this gave you a taste for what a real challenge looks like. Thank you so much. Happy to take any questions.
One of the very good points you mentioned is that output versus outcome, right? So we typically just care about output, but actually what matters is the outcome, right? But actually, if you look at all the startups and right now all the trend which is going on, like any startup you ask, they start with AI-powered, AI-based, and that itself shows that their main focus is, so they never start that this is the problem they are solving. No, they will always say, we are building AI-powered voice recognition system, suppose, for example. So my question to you is that, don't you think that the trend should change, that the students, especially let's say this college, right? The students should shift the focus from technology only, as you mentioned, right? That the outcome is more important. So I think that current ecosystem of whether it's VCs, investors, everybody is nowadays just running after what is the AI application here? Like, it's the direct question, whether AI is actually needed or not, but they ask, where is the AI here? So my question is, what do you think?
So see, I mean, your answer is implied in your question, which is that we should be looking at really what problem we are solving. I'm happy to share separately a framework. We typically ask whether, I mean, AI for X is like the flavor of the day, right? But is it a good idea is what we ask before we typically start. We ask, is this a big problem, really? And what is the precise problem that AI is expected to solve? Is AI feasibility there? Is AI necessity there, right? And these are, and is the data going to be there or can be collected in a reasonably economic manner? Do we have collaborators with whom we can co-create on the ground, right? Not just build something throughout on the ground. Do we have scaling partners? Do we have financial sustainability? All these are questions we typically ask as part of the process of deciding whether we should embark on doing something or not, right? We can't change hype cycles. We are in a hype cycle. Let's use it to our best advantage. That is, let's try to get some attention from technologists to problems that typically might not otherwise receive attention, for sections of society that might typically not receive attention, right? And if we can use this hype cycle for that, that's great. Hype cycle will be hype cycle. Sure. Yeah, there are folks who can give you better up-to-date information, but right now across 4 or 5 districts in eastern UP, with frontline health workers, it is being deployed. I think something like 2,000 frontline health workers. A&M, all the A&M cadre folks are using it. We have human-in-the-loop evaluation from experts. That's at 96, 97% in terms of the responses all the responses are being rated. Similarly, every response that is given is also rated by the recipients of that response, the frontline health workers, to say whether whether they were happy enough with the response, whether they could move forward with it because of it or not. That is also at 96 to 97% currently. Perhaps the biggest, the metric that perhaps is most encouraging for us is the fact that the number of queries that were going to the medical officers, because essentially what we are trying to do is lots of regular queries around high-risk pregnancies go to medical officers. And they are overwhelmed. They don't get response immediately. They get response in hours, sometimes even more than a day, right? I don't know what the response times are. Maybe Sanskriti can tell you exact what. But the number of responses that are going to them have come down to something like 14%. So which means we have reduced the burden of the frontline, the medical officers by 86%. And these folks are getting the response they need to the queries they want immediate response to.
What is your backend and LLM, is it?
So actually, the series of things, we can talk about that offline. There are various models that are being used for various tasks, right? Yes, there is an LLM at the heart of it, of course, but since these are multimodal, right, code mixed queries, you can imagine there's various things that have to happen. First, to make sure that we understood the query the way it was meant to be, right? Then to say whether or not we actually have the knowledge and in the context to answer the query, then to synthesize a response that is in a way both that is accurate but also is useful and actionable for them. So all these things are measured, right?
What's your view on security per se for the voice-enabled bots? Especially, okay, I used to feel like when my kids used to play on Alexa or anything, even the neighbors, okay, they will come to know all unwanted, okay, details easily, okay, they will get. Vice versa is also happening. This is a pretty way. So
I'm
from
not
the security point of thing, when we are orally telling, unknowingly or knowingly, we will be leaking out so many, secret, data.
There are a lot of issues around. I'm not an expert in this at all by any stretch of imagination. It worries me too. I worry especially about a day when I cannot distinguish a bot call that might sound like my kid's in trouble.
Yes.
That's what I worry about, right? And or my mom in trouble who is not at all. My kids might at least be. They will be more tech savvy than I am, but certainly not my parents, right? So I don't have a good answer to this, and I just hope the big companies who are deploying this sort of technology are able to help us with this, right? So.
Hello. My question is on that bot that we also work on a similar kind of bot. It is mostly for the aversion, safe aversion. And we faced a challenge that on evaluation side, it changes with the bot time period. Like when we at the launching time, there were the different challenges on evaluation. When it goes on the field, different. And when we get the messages from the FCSV, from community health volunteers, like
it's entirely different. Yeah. It basically means the data set on which you had started working with iterating on was never representative of your field setting.
So the data was collected in different way. Like they were on the field also, but I want to know more what is the evaluation things is carried on this chatbot later on also, so that I can improve our evaluation system.
I'm not the best person to get into that level of technical detail. Do talk to team members here. Sanskriti is sitting right there. Do talk to her. But the general experience, by the way, this is not just about voice tech in general. We have found this surprisingly so even in what we might consider as fairly mature computer vision challenges, right? So it is very common for folks to develop AI in hospital settings, working with doctors. That you think you brought together a good enough data set, all that. You'll have a performance, then you go out on the field, then you have field level operators with field level equipment, then it doesn't work, right? So I think as part of your use case definition, all this has to be very laid out in quite a bit of detail, right? For example, you might say, ASHA workers speaking these variants, right, of this language in these districts asking queries about such and such thing, right? Because the terminology you're going to get, let's say, in a general conversation is going to be very different from a medical specific conversation, right? And it's incredible how different these terminologies can be, right? And how one term can mean different things in different cultural contexts, right? So a lot of it comes down to those sort of, really understanding the deployment context.
Thank you.
I don't know how much organizers, please cut me off at any point you want me to stop talking. Last question.
Sir, as I told that your system is deployed in Eastern UP, districts of Eastern UP. So what language do most interactions are in? These are in standard Hindi language or localized?
No, standard Hindi language, forget it, right? These will be things like Maithili, right? Bhojpuri. I don't know what other languages we run into.
Bhojpuri is mostly spoken in that area, and standard Hindi is officially.
So there seem to be a lot of variants. Sometimes we actually don't know the variant. At some level, I don't care about what the name is of the language. We just want to bring to the right corpus from that area to know that it works in that area. In most situations, in most of our settings, it's actually quite a mix. You'll find people who are speaking what you might call regular Hindi, but who the hell are we to say what is regular Hindi? That's a very pundit, I'm the person to say this is the regular Hindi sort of thing, right? So we actually don't get into that. We instead say, what is the variety of language that's spoken, and can we understand that?
Okay, but you respond, your bot responds in standard Hindi only.
What response in whatever Hindi is understood there.
It is standard Hindi. If the user has chosen Hindi, we do support English as an output option as well, if the user prefers that. And it's usually code mixed. And all of that is by design. So we, like Raghu mentioned, we've worked with design teams. And the feedback we've gotten from the ground is that users prefer numbers to be in English, specifically ANMs. So 100.4 degree fever is easier to understand compared to 100.4. Yeah. So those are nuances that are included in when we send the response. So it is standard
Depends on the user preferences. Depends on user preferences. But your point is very well taken. At what point can we start talking to them truly in their native tongues, right? I don't know what that challenge is, and I don't know. It may be worth solving, but first let's talk in a way they understand. Let's understand them, whatever they are speaking in, and then give responses in a way that they understood, right? And that bar we are meeting, because they are responding that they understood and like our response and have been found it useful up to 97%.
Sir, at Artpark, you are mostly doing with only robotics kind of thing, or even
broadly, this is also work we are doing, right? So AI and robotics broadly. With that, thank you so much. Appreciate it. And again, I am very much an imperfect messenger for the technical metrics side of this, but hopefully you got the gist of the message, which is keep the real impact you want to have in mind and work backwards. You're all engineers. I'm sure you know how to come up with the right metrics for the right impact. Thanks.
Thank you, Raghu, for such a thought-provoking session. May I now invite Mr. Nihar to present small token of appreciation to Raghu. We now come to the final and most anticipated segment of the day. But before that, we would like to take a moment to sincerely thank our jury members for their time, thoughtful evaluation, and the constructive feedback. I think your expertise and insights have played a critical role in shaping the outcomes of this hackathon. I would like to now call our jury members to please come forward. Aishwarya Salvi from ZIZ. May I request Prashanta to give small token of appreciation to all the jury members. Can I now request Anushuya Richel from Shivnadar University? Yeah, just call. Sorry. Yeah. Please stand near the dais so that we can have a group photo with all the jury members. Next up, Hema Murthy from IIT Madras. Next up, Sanskriti Mida from Art Park. Next, we have Saujanya from Arman. Finally, we have Sunaina Sitaraman from Microsoft Research. Thank you once again, all the jury members. We now come to the award ceremony of the CISPIN Voice Tech for All Hackathon Round 2. Over the past few months, teams have worked across datasets, models, and real-world use cases, all guided by a common objective to build speech AI systems that are inclusive, scalable, and relevant to India. The jury has evaluated the submissions on multiple dimensions, including quality of speech, synthesized novelty of the approach, technical write-up, and the poster presentations, and the PowerPoint presentations, and the Q&A. Now, I would like to invite Raghu Dharmaraju to give the award to the second runners-up. And the second runners-up are Somya.ai. Let's give a huge round of applause to the second runners-up. Once again, congratulations, team. Now I would request Aishwarya Selvi from ZIZ to please join us on stage to give the check to the runners-up. And the runners-up are LTRC-SPL. Now, finally, the moment we have all been waiting for, the winner of the CISPIN Voice Tech for All Hackathon Round 2. May I request Hema Murthy to please come forward and present the check to the winning team. And the winners are Immverse AI. Huge round of applause, guys. May I now invite Sunaina for, to present certificates and bouquet to the fourth team, CDAC-SVNIT. Prashant. May I now invite Hema Murthy to address the audience and share her thoughts on the hackathon.
I think it was a nice experience on the whole, but it comes with a caveat, and I do feel that science is taking a backseat and Indian languages are actually taking a backseat. I would like to encourage that all these young participants who have done so much work also look inward and not westward. It would be really nice to, a lot of work that's going on in the language technology side, especially from linguists and acoustic phoneticians. And please leverage that knowledge into these systems that you build. I think that's very important. I think China has a DeepSeek. Let us have a DeepSeeker. Okay, I think it's time we did it. We are also a 1.4 billion population. I'd like to see that and a very small footprint at that. I think next time it should not be anything that runs on the cloud. Thank you very much for asking me to be part of this team.
I request all the finalist teams and the jury members to come near the dais for a group photo. All the participating teams as well. I think I request Prashanta also to join the group photograph.
To put the last slide or nothing is there. So you can announce.
I would thank all the online attendees and the offline attendees for joining us here. As we conclude the award ceremony, we would like to reiterate that the end of this hackathon is not the end of the journey. The ideas, the data sets, and the collaboration formed here are meant to carry forward into the real world deployment and continued research. And thank you very much once again, all of you, for joining us.